Hello everybody. This video today is going to be covering a video that somebody named Dave, his channel is Professor Dave. He did a video called "The Earth Still Isn't the Word You Can't Say." So what I'm going to be doing is I'm going to cover this video. I'm going to give a lot of like context and backup to support claims, a lot of the claims, and kind of have a response to this video. He will say something that's very important here starting off, and I'm kind of recording this in a different fashion, so we'll see how it turns out. So what I'm going to do is basically I'm going to just play the video and then I'll respond to it. But what he does start out with here is something that I think is very important. So I'm going to go ahead and play this video.
Out. I didn't really know what to expect. I thought there'd be some degree of dialogue or exchange. There definitely wasn't. Everything they were saying I was discrediting in real time, and they were acknowledging none of it. On top of that, they were extremely rude to me, so I had to respond simply as a point of honor, and that's this. So let's begin.
So that there, before he even begins, that is a very important thing to acknowledge. People in the flat... people who are discussing cosmology, people who are talking about these things, who might offer different explanations to phenomena against guys like Einstein or Newton. These people that have these views can definitely get ego. They can definitely have pride. They definitely do have a condescending tone, and they talk down to people and they name call. And I don't like to edit my videos. I try to do as minimal editing as I possibly can. I even just like to record voices in one go and just, you know, kind of go with it, because it's to me it's more of a conversation than that way. But what Dave says here is very true. And I completely agree with him. Don't waste your time insulting people, talking down to them. Never talk down to people. I believe you shouldn't, because you never know what somebody else knows, or how they think, or this or that, which could help you. You could gain more insight, another perspective. Don't ever talk down to people. If someone is wrong about something, you can correct them politely. You don't have to name call. Why would you waste your time? If you believe that the earth is biblical, then why are you wasting your time having or putting out put downs and saying those things, when you should be, if time is of the essence, you should be using your words as effectively as possible and getting as much out in as quick of a time as you possibly can, because we are going against an entity right now that is after our lost brothers and sisters. So we have to be very diligent. We have to be very respectful and courteous. And with that said, I do like to record things straight. With this video, I recorded Dave, and now I'm going to respond to it. But what I'm going to try to do is I'm going to make a few tweaks, but what those tweaks are is kind of like what I did with the video I just posted about a pharmacist. I had to kind of mute certain words, and hopefully there's no like algorithm, to get around like the rhythm. So with that said, yeah, I'm gonna do a few. I'm gonna like try to cut out the insults, because there are a few that go back and forth, and we don't really need to hear that. I'm already rambling on as it is, but I want to put as much information into this video as I can, so I'm gonna try to do as little talking as possible and let this video roll, and let the rebuttals roll, and everything. And yeah, just really, that's a big thing to me, is just be respectful. We're all trying to move forward here and progress as mankind, right? So, you know, let's try to do that. So I'm going to get back and play this video here now.
I'll start with the only valid criticism you had of me, and that is that I misrepresented your model and didn't research it enough. You're right. I didn't look up almost anything you believe.
That's a very important thing, actually, too, is not researching. If you're going to critique somebody, if you're going to go against them, for their view. You should know what they're saying. You should really listen to what they say. You should look up what they say or ask questions if you are curious about this or this. Don't try to pick apart biblical earth, and represent it with the biblical earth being in a heliocentric model, because that's not the claim at all. So don't straw man. It doesn't make sense to pick apart something that's not even being contended. You want to actually be thoroughly refuting everything that is being lobbed against you, and be able to sharpen the iron, so to speak. You want to be able to get through your counter. You want to be able to properly refute whatever argument is being raised against you and quell it, so that you are able to logically break something down, potentially have more of a chance to sway that person to see why your side is more logical, or whatever you're talking about. So that's a really important thing. Okay, back to it.
But now that you've told me so many of the things that you do believe, even better, let's go through how all of them are wrong. Since I botched your model so horribly, let's go straight to yours. This is the one you showed me to explain the seasons.
So the contention is on the earth, not the sky. So the first thing that he does here is go to the sky. We're trying to determine, we're not focused on the sky right now, we're trying to determine the geometry of the ground, the land, the sea that we walk on, not the sky, the air, and things like that. Let's just talk about the ground that we can test. As above is not always so below. That teaching is not correct. Like, here's an example. If you were going to say, because things we see up in the sky are this or that, so it must be here, that's like saying that because in baseball you hit a round ball with a round bat and you try to square it up, as you round the bases for a rounded batting average, then the ball is pitched from a rounded mound, that the field that you're playing on must also be round. But it's not. It's planar. And we can test for the planarity of the earth, because you can see lights over water that are completely even, and there's a physical geometric drop off for an earth that is a globe. It would have to be there, and it's not. It's planar. It's a characteristic of water. So we're discussing the characteristic of water, because land can contour, and water is planar, to match biblical cosmology. So it supports, or isn't actually really an evidence of biblical cosmology. It's empirically determined. The other thing that we're going for is the motion to the earth. And if you're going off of a globe and you're going with that cosmology, then you would have to have probably relativity. You're probably going with Einstein to some extent, and he himself said that you cannot determine motion to the earth. It can't be there for his ideas to have a chance at being shown true, because everything needs to be relative. So you can't detect against relative things. So we can't tell the earth is moving from the earth, according to him, because everything would be moving with it. So it would always appear still. So it's your interpretation of that. Then what does that lend more credence to if you do a test and see it still? So we're talking about what the earth is doing, the stillness and the planarity of it, and that is what we're going for, not what the sky is doing. So I think here, like, he's going to talk a lot about the sky, which, I mean, he almost kind of has to, because we can see too far and we can measure no motion. So
It attempts to account for the temperature differential throughout the year, but I'm sorry, it's not compatible with observation. Here's why. These are the two tropics. I don't know what you think these circumferences are, but it's safe to say that this one is smaller than this one. If that's the case, one of two things must be true. Option 1, this object maneuvers the inner path in a shorter amount of time than it maneuvers the outer path.
This is not true. The sun will always keep a 15 degree per hour heading, no matter which tropic it is over. The sun will always maintain this. The sun does speed up as it goes further out, and it does slow down as it gets closer inward. This is because of, if you look at like a bike wheel and think of it kind of like a magnetic field, like a toroid, you can actually see how it would stay on the same rate of rotation, but it would speed up because the further out you go from the center, the faster you have to move to stay in line, because all of the field is all moving as a unit. So one line will always keep the same heading. So the sun does speed up and slow down just because of how far it radiates in or out. But it does always keep the 15 degree heading, which is what we observe.
Which would make summer shorter than winter. It's not. Option 2, it moves much slower up here and much faster down here, so that all of the circles take the same amount of time.
The thing that determines how long the seasons last is where the sun is over what part of the earth between the tropics is the sun directly overhead. The sun is only overhead in between the tropics. And if it's in the northern tropic, the inner tropic, it's going to be summer here in the north. And if it goes out to the outer tropic where the sun is further away, it gets colder and you have winter here. And then it passes through the equator twice. So you get a warm up and a cool. And those are spring and autumn, because we have the seasons are still equal though, because the sun keeps it takes roughly 180 days to get to from one side to the other, and then another 180 to go back. So it's the same distance, so the seasons are the same.
That would mean the sun moves through the sky at different speeds throughout the year. It doesn't. So sorry, this model doesn't work.
Actually, it's not the change in speed that is important. It's that it keeps its 15 degree per hour heading.
Now let's go to the one you showed me for night and day. We all know that precisely half the Earth is experiencing day and the other half is experiencing night at any given time. So your model must reflect that, and this one does, but at the cost of being even remotely reasonable. You've got the sun illuminating half this surface with an arbitrary and rigidly straight line down the middle. How does this work?
So as you can see in that video there, it does show you how the sun, which is set in the firmament, so there is glass between us and the sun. You can see how this glass causes this distortion of the light casting, and how it's able to make these shapes and get these bends that are shown on the bottom of the Gleason. So that's kind of showing that it is possible to get these types of lighting patterns, and you even can get the outer edge lit for the 24-hour light in Antarctica. That's something called the coffee cup caustic.
How does light leave this object and travel one distance to stop here, and travel some totally different distance to stop over here? You guys love to talk about refraction and such things, so please explain how that works. And that's not the only problem. Here, you've got the sun and moon always opposite each other. Well, sometimes we can see the sun and moon at the same time. How does that work?
What the sun and moon do is they actually they travel at different speeds. They cover a different amount of degrees per hour compared to the two. They're different numbers. So if you have the sun and moon at opposite ends, one of them will be traveling at a different rate of speed than the other. So it will appear to gain on the other lights, and then as it'll catch up, it will then, because it's going faster, it was, so that's why it was able to gain up on the light. Now it will go past the light and go back to being opposite and back and forth. They're chasing each other and running away from each other, essentially.
What is an eclipse? When in this model does the moon get under the sun to block it? How do they get on opposite sides of the Earth for a lunar eclipse?
Eclipses work because for the solar eclipse, it's still the sun and the moon overlap, and whatever type of hyperdimensional transmitter it is, they're able to block one another out. The moon is, as far as a lunar eclipse, which I believe is what he's referring to here. The lunar eclipse, if you're considering another way of thinking, another worldview, another way of explaining things, you can't carry over preconceived notions that you have. So something like the moon must be reflecting sunlight is not true. The moon actually is claimed to be its own light, its own source of light. So you have sunlight and you have moonlight, and they have different characteristics. The sun is yellow, it's warming, and life is active during this lighting, and life grows and is nourished by this light and needs it to survive. Moonlight, on the other hand, is the exact opposite. Moonlight is silver. It's cool in moonlight. It's colder or I should say, not necessarily in moonlight, but in shade, night shade. So the heating properties are different. And you also have life behaving differently to the moonlight. You have things putrefy in moonlight. Fires behave differently. So they're a different type of light source. And so the lunar eclipse is actually the moon. It has systems and cycles built into it because it's part of a timekeeping device for the months. You actually can track the cycles of the moon on your hands, in all the segments of your hand. They can actually be a calendar on your hands for a lunar calendar. But the moon has built-in cycles, and so it will change its color to a red color every so often, probably having something to do with signs, with things that are biblical.
If the sun is very, very close and is also the source of all our heat, why doesn't it get hotter when you go up towards it in elevation?
It does get hotter as you go up, especially when you get into the thermosphere. It definitely does get hotter, in part due to the molecules up there are closer to the sun, so they have more energy. It could also depend too, as far as the layers in between the troposphere and the thermosphere. You do kind of get density gradients, different gases and particles settling at different levels. But it does get hotter up there. That's actually something that people who are of biblical earth are typically say is like, why wouldn't satellites melt if they were up where it's 2,000 degrees or whatever, however hot, when metals melt at a lower temperature? And the thing is that there's less particles in the air, so they are moving faster, but there's so few of them that it doesn't feel as it would if you were closer to the ground. and also why there's can be like a little jaggedness to the temperature as you go up. I mean, could have something to do with the ground and the water down here absorbing heat. I mean, water has a very high heat specificity, so it can store a lot of heat and hold on to it for a long time. Um, but there's more water vapor down here, so especially by the water, and so you do get an increase in temperature of as you go up, as well as people have shown hot spots. So which only happen from a local light source. There's a hot spot and then it radiates outward with the inverse square law of light, causing the light to decrease in its intensity as you go out. And that is also indicative of a local light source. The hot spot is.
Honestly, I could stop right here. If you were to respond to this with anything other than a model that can explain at least those first two observations simultaneously, your viewers should find that very indicative of the fact that you don't have one.
So we did go over that you can actually get the phenomena that you're asking about with the seasons and the lighting, because the sun does move between the tropics. It does make a smaller circle and a wider circle, and this can produce the light with glass domes, not even taking into account water, can give you lighting patterns that do exhibit an odd shape when you express them two-dimensionally, but you can see how they get that contour from 3D lighting in that video. So you get the lighting and you do get the season change, and I think it's also reflected with the warmer. Later he'll talk about ecology, but it's because it gets brought up in this video, ecology. Dave doesn't bring it up, but that you do get warmer temperatures because the sun is covering a smaller area and making smaller circles, so there's an average greater heat, plus less water in the north helps too in the inner circle.
Models are used to help show and describe things. They aren't necessarily needed because we can empirically determine and establish the planarity of water as a characteristic of water. And we can also show that the Earth has no motion, that is still. So we don't need models for the sky, though they can help to kind of get an idea. We might not know every single detail. But again, talking about the sky when we should be talking about the ground. But models, I can ask you to model for me vacuum next to gas pressure without a barrier in between. Model it for me. Show me an example that it can happen, but it's, I think, admitted that it can't because you would need something to the scale of the size of a planet to get the gravity. So, okay, you can't model your claims either.
But while we're here, let's go through a few dozen more key points. Given that we're on the subject of models, let's hit the one you use for your explanation of the Coriolis effect.
You can kind of draw a clockwise orbit, Bob, in the middle there. And you can see how this would cause, there you go, if the sun and moon are moving in this and, they're diamagnetic and pushing water, causing tides. And then you've also got these winds that and storms that would, have to be what the sun and moon would cause.
Would have to be? How? You haven't explained anything.
I would tend to agree here a little bit with Dave because I don't think it's proper wording to say entirely caused by the sun or the moon. I'd say it's better to say that it's likely at least partially due to at least the sun, maybe the moon, because we do know that things like weather and currents and tides do have heat as a contributing factor that does influence, what kind of weather you're experiencing, or tides. Temperature plays a role in those things. You can also get things with tides, like if it was caused by the moon, it would pull on all bodies, but not all bodies of water experience tides. Some don't experience any at all. and you even get inconsistencies in the tidal height. Even going along a coastline, you can get some tides that are a meter, maybe a couple meters. You can get some that are a fraction of a meter. So I think the tides has a lot more to do with like the basin of the what is experiencing the tide, and maybe even currents as well. So there's a lot of factors that go into it. So I don't think that it is just the sun and the moon.
So the sun pushes water to get the air currents, and the moon pulls water to get the tides? Also, does the sun push the atmosphere in one direction to the right and magically in the other direction to the left? What about storm rotation, which is what this whole thing was about? You've made no attempt to even put the sun and moon in there and physically explain anything. You just say words relating to electromagnetism and hand wave it away. And another thing here, guys, even if we grant you this magnetic magic that you're looking for, it's still inconsistent with your model. Here's why.
The line going through the middle of the screen, if you picture the sun traveling from the right side of the screen to the left, it would create those same wind patterns above and below it.
Sorry, didn't you say that the sun moves from tropic to tropic? In that case, the boundary that divides the direction of storm rotation would also move from tropic to tropic.
Why you would get certain storm rotation on the inner circle and certain storm rotation in the outer could have something to do with if it is partially the sun, partially luminiferous ether, having something to do with multiple variables. That the equator region, that equator circle, could be the middle point where something happens. If you look at like a 3D version of a magnetic toroid, you can see how there's like a middle point where it like goes through itself and comes out the other side. That could have something to do with it. We're still trying to figure things out and learn how to explain phenomena of like weather and the sky and everything. Again, though, not the ground. That's
so the energy that got the water up there in the first place is all solar. So you should think of hydroelectric as solar, as well as wind energy, because wind is the unequal heating of air on Earth's surface, and that creates air currents. That's also solar power. It's all solar.
Also, why wouldn't compasses follow the sun through the sky?
The reason that compasses do not follow the sun through the sky is because the compasses are attracted to Polaris. They're attracted to the magnetic pole at the middle, not the North Pole, which actually, or not to they're attracted to the North Pole, not to the sun, which actually is a big point too when it comes to like circumnavigation. North to south to north navigation, where you go directly straight 180 degrees through the South Pole, has never been observed. It's never happened. No one's ever shown a compass flip like that. So that actually further validates you can only go across the circle, take the diameter of the planar biblical Earth, rather than having to be able to go straight through the South Pole.
Also, why wouldn't storms speed up during the day while near the sun and slow down at night when the sun is away?
So weather is a day-to-day type of thing, whereas climate would be more long-term, over many years. So weather is day-to-day, and why there isn't like a speed up or a slowdown from day to night is because it's all just average. It's a gradual lowering of the temperature as it goes towards night, and a gradual increase in temperature as the day is brought about.
Also, if you're claiming these southern winds are so incredibly fast, how is that possible if they're the furthest away from the source of the effect? In actuality, the Coriolis effect is just the result of basic physics relating to rotating bodies. That's why the equator is the dividing line. Pretty simple, don't you think?
So what he says here is he makes it sound simple with the explanation for a globe. When considering the alternative cosmology, you could say it has to do with the sun's position rather than the Earth's turn. So you can get pretty simplistic as far as like an explanation goes, but you can kind of unpack more and go more in detail and everything.
You can delineate a lot more and add a lot more context, go more in depth. The other thing too, though, is like in this instance, he does describe something simply, but consider this then as far as explaining phenomena as simply as possible. If you have on a globe model, we're told that if you drop a stone, it will fall because the stone is heavier, or because the stone gets pulled by gravity. And if you let a balloon go, you're told, and it floats up, you're told that it floats because of density, not because of anti-gravity.
Simmons was transported to the launch site, an open pit iron mine 2 hours north of Minneapolis.
I never get tired of seeing a launch. You think how thin this material is, how much the balloon itself weighs, how much the payload weighs, and how much lift is in that balloon. Not like a rocket with a bunch of fire and noise. It's something completely unique and beautiful.
A mobile command center allowed Stapp and Winsen to keep in contact with Simmons throughout the flight.
Dave, what is your rate of ascent now? Roger, thank you. What are you reading now, Dave, over? 25,000. Very fine, Dave. Capsule pressure should be holding now. You start 25,000. Is that roger? Over. All right. I think we should try to maintain the altitude as we previously discussed.
As the balloon leveled off above 101,000 feet, Simmons focused on his regimen of over 25 experiments and observations.
So you use density for one and gravity for the other, whereas in a biblical model, the phenomena explanation would be that density and medium are what causes up or down. If the object is more dense, it will fall because the medium cannot hold it and sustain it at the energy level, so it will fall to the lowest energy level. And determining on if the medium of the density is greater than the object, then the object will float because its resting energy is actually above. If the object is heavier than the medium, it will sink, it will fall down, what we call down, because the lowest resting energy is in that direction, and it will seek this energy constant. It will seek this resting energy at a constant, which is 9.8 meters per second squared. So it's you can say there that's density versus gravity, or using density and gravity to explain for one model and density alone to describe for the other. And then I went more into detail. You can unpack, you can simplify. How you want to do it is up to you, but it's how you explain it.
Astronomy and astrophysics and all of that, Dave, these aren't even real sciences. Okay. Now, you obviously are going to claim that they are, but the reason that they're not real sciences is because the only thing that you can do is observe them. You cannot test them. You cannot do anything to be interactive with them. You cannot generate hypotheses or experiments or anything like that. All you can do is simply observe.
Sorry, guys, that's dead wrong. There are hundreds of examples I could choose, but I'll use this one. In the 19th century, we noticed irregularities in the orbit of Uranus. We realized these irregularities could be explained if there was another planet perturbing its orbit by gravitational influence. We did some math and predicted that there should be another planet in a particular place. We looked in that place, and what do you know? There it was. You can't get any more empirical than that. Do some math, make a prediction, the prediction is verified. The discovery of Neptune is a great example that corroborates Newtonian gravitational theory and demonstrates that astronomy is an empirical science, just like any other.
So I would actually kind of agree partially with Dave here again, because in science, you actually do use observation. Him saying that it's only observation, you do need to be able to observe things. So Bob's saying like observations are not, he's not really saying it, but in a way it's like observations don't count when really they do. That's actually what helps refute the globe and evolution and things like that, is because their key essential elements are not actually observable. It's all on inference. As far as the prediction of an orbit of a planet, They're actually, I mean, they could have known about, the ancients could have known about all of the wandering stars. They would all be there. They could, we don't know what they had back in the past, especially in the days before the flood. So that it could have been known that it was there in the orbits, and then they just wanted to say, this is how we'll explain it here. As far as, you know, discovering this, because you didn't go there, you didn't test the gravity or anything. It's knowing the orbits. It's knowing the orbits that have been known for a long time, back into ancient antiquity. They used astrolabes in these things, and these were all using a centric Earth, and so these things can be shown. The circles for orbit will either be around the Earth or above the Earth, but it's still circles. So it's all knowing the orbits, and the sky has been known accurately for a long time.
Based on Babylonian observations, the Greeks built a machine to look into the future and forecast eclipses.
Amongst the whole mass of symbols, I found this symbol in the document. It was short for the word aura, meaning hour. So what that told us was that not only did this mechanism predict eclipses, but it predicted the hour of the eclipse as well. As the hand sweeps along the scale, here it's just reaching a lunar eclipse, and here then we've got a solar eclipse in this month, followed by a lunar eclipse in that month. Our research group pooled our resources in a discussion on the internet, and Yanis Bitsakis in Athens found the phrase, "the colour is black," in the eclipse inscriptions. Alexander Jones in Toronto found this really exciting, and he then discovered the phrase, "the colour is fire red."
We were discovering a very sophisticated machine that not only was predicting eclipses decades in advance and what time of the day or night they were happening, but even the direction the shadow was going to cross and what color the eclipse sun or moon was going to be.
Michael Wright made an absolutely brilliant observation from his X-rays. He discovered that one of the gears at the back of the mechanism, mounted on this large 223 tooth gear, had a pin on it.
This is the pin and slot mechanism. There's a wheel in the back of the instrument. You can see with the naked eye that it's got some sort of a slot in it. The next thing you see is this round ghost in the slot. There is a pin.
But Wright couldn't figure out what the pin and slot were for.
And he threw the idea away. It's a tragedy for him in a way that he had this absolutely the most brilliant observation in the history of the mechanism.
I didn't know what it was doing there. I even came to wonder whether it was a sort of mechanical fossil.
But he made this other very critical discovery. He discovered that the gear with a pin turns on a slightly different axis than the gear with a slot. So this mechanical device induces a variability in the motion of one of the gears.
When the wheels are like this, and the pin is at the inside of the slot, the driven wheel on top is going fast. When we come round here, and the pin has moved to the outside of the slot, the driven wheel is going slow. And this is modelling the way that the moon's speed in the sky actually varies.
I was on the plane to Athens. I was playing around with the figures. I knew the input gear had 27 teeth, so I put that into my calculator and calculated the result. And to my deep disappointment, it was too big. So I thought maybe it's only 26 teeth. So I put that into the calculator, and it was too small. Now, I was a mathematician, and mathematicians often have slightly crazy ideas. So I tried putting in a gear with 26.5 teeth, and I pressed the key on the calculator, and the result was 0.112579655. Exactly the right answer to 9 places of decimals. It just hit me like a thunderbolt. Twice 26.5 is 53. Michael Wright had been correct about the 53-tooth gear. The riddle of the 53-tooth gear had been solved at last. It turns the large 223 gear with just the right 9-year rotation, so that the pin and slot exactly models the ancient Greek theory of the moon's variable motion.
Yeah, absolutely. Like if you're doing an Olympic, say, long jump event, I would always opt to jump from east to west because, you know, where you're going to land should be racing towards you.
No. When you jump off the Earth or take off from the Earth, you retain the momentum imparted upon you by the rotation of the Earth. This has nothing to do with the atmosphere.
A exchange that I had with a professor at my school, and she's a physics professor, and so I had kind of an exchange with her. I going back and forth. I was asking her about a few things. We were talking about a couple things. So I wanted to read part of this email because it relates to this rotation thing. It's a question that I pose. So I said that the main thing I wanted to ask here is about the 1,500 miles per hour conserved speed. If this plane is going 1,000 conserved, once it touches down in, say, Canada, where the Earth is rotating roughly 500 miles per hour, won't the plane have a kick down to 500? So basically what I'm asking here is I'm saying that if a plane takes off at the equator where it's spinning 1,000 miles per hour, that plane is conserving 1,000 miles per hour of conserved speed. Even with the engines off, it's supposed to be conserving 1,000 miles per hour. So if this thing lands at Canada where it's going 500 miles per hour, I'm asking if there would be a kick down where the plane physically should go down to 500 miles per hour from the 1,000 that it conserves. And then she said, hi, Nathan. Yes, the plane will have to kick down to 500 miles per hour to match the Earth's speed at the higher latitude. And then, so she said, thinking about, because I asked her about east-west flight, so she said there would be a kick down, which if you think kind of like about a treadmill, if you like jump down onto it from not moving, it's gonna slide with you. It's an absolute motion. The thing about rotation is it's absolute. If you're rotating, you can easily go with what's rotating, or it'll be more difficult to go against what's rotating. That's just linearly, not even curved. If you run on a treadmill, it's harder to go one way and easier to go the other. So absolute motion is a thing if something is rotating because it's definable on the axis. You have a reference point, so it's not all relative. So this motion can't be felt, so that's a big thing to know. Actually, just kind of hitting me now. Like that's really that's an absolute motion that is not detected and should be measurable. And every time we try, it turns up null. Every time. There's no way to mechanically, physically, empirically determine if there's motion. It always is zero.
So what he says here is very true. I don't know if it's more true than he is aware of and what he is conceding when he says this. But if you do have a rotating Earth, even with its gravity, it wouldn't affect the atmosphere. Be affected by the atmosphere, which he's right, because on a molecular scale, on an atomic level, the molecule's dominant forces that it's being influenced by are electromagnetism and the strong and weak force by far. Gravity doesn't really play any part, and this would give you some whip. The higher up you got, there would be a drag behind, because the things that would be the closest would be, if it were caused by the atmosphere, would give you that change. But the thing is too is what you have to consider is that there would be drag, because think about if you're at the bottom of a 3-foot pool and you run your hand across the bottom of the pool, air and water are both fluid. So if you ran your hand across the bottom of the pool, how fast would the surface water be going in the direction you dragged your hand? The water next to your hand would be going fast and move, but the further up you got, the less slow it would be. And after 3 feet of liquid, it would be hardly anything. And liquid is a lot more connected than gas particles. Those molecules are fluttering about randomly, whereas the liquid molecules have a lot more interaction with one another.
10 to the minus 12 centimeters, which is 10 to the minus 14 meters, and you calculate this ratio, you will find that it is 26 orders of magnitude higher than the gravitational acceleration on Earth. 26 orders of magnitude higher. So you wonder what the hell holds the nucleus together, if there is such a tremendous force on these protons. Well, what is holding them together are the nuclear forces, which we do not fully understand. But thank goodness, the nuclear forces are not part of 802, so I'll leave that alone for now. So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together.
It's also very easy to prove. Stand on the back of a moving truck. Jump up. What happens? Do you fly back off the truck at 30 miles an hour? No. You land right back where you started, even though the truck has moved forward while you were in the air. Why? Because in the air, you retain the forward momentum of the truck. When you jump off the Earth or take off from the Earth, the same thing applies.
Here he's talking about things moving with the atmosphere, Coriolis, things like that. And what he does is he starts with an example of somebody throwing a ball on jumping on a truck, someone jumping on a truck, and then they land back down on the bed, even though the truck is moving at a constant speed of 30 miles an hour. But then he goes to the Earth, and this is a different thing now because the Earth is actually orbiting and rotating. So it has two curved motions, and curving, if you're not going straight, it's considered constant acceleration if you're moving. So if you're orbiting, if you're rotating, you are constantly accelerating, which is felt and is applied to these things. So it's actually inaccurate for him to compare a straight moving truck to something like the Earth, which would be considered always accelerating. And you do feel change in acceleration.
If you do a test on a train or, like you said, on a plane, and just simply jog from the front of a moving train to the rear and maybe time yourself or just observe, and then do the same thing running or jogging to the front of the moving train. I've done this myself. I promise you that you'll find that it is much easier to run from the front of the train to the rear.
That's your test? Pretty tough to reproduce, don't you think? Here's an idea. What if it was harder to jog to the front of the train because the train was speeding up slightly? Try it again when the train is slowing down. I bet your results will change.
I mean, it is easier to go with the motion than against it. Again, though, they're talking about a straight train and the Earth is rotational. So if we're going for rotation, then something you could do to show how you would deviate off your straight course and go off in a tangent, you would... what you could do, I won't recommend, no one do this, but like I did it. I went into my car into an open parking lot and I spun the wheel. I held it tight so I was doing like a donut, and then I would throw a ball up in the air. And I mean, as he'll get to here, like if you're throwing a ball back and forth on a straight moving object, it'll appear like you're not moving at all. But if you're turning like I was in the car, you will see the ball instantly deviate outward. It wants to go away and fling off, and so it does deviate its course instantly and constantly because it's constant acceleration.
Sorry, this is not a valid experiment.
25-mile target from the New Jersey has a flight time of 90 seconds. So you're aiming 90 degrees from the ship straight to the equator to hit that lighthouse. And it takes 90 seconds for the bullet to get there. Problem is, in 90 seconds at the equator, the Earth moves 25 miles. So it takes 90 seconds for the bullet to get from the ship to the lighthouse. But in that 90 seconds, the lighthouse moves 25 miles. So you're going to miss it by 25 miles.
The boat and the bullet and lighthouse are all moving around the Earth together, and the bullet will continue with the same momentum that the boat has once it leaves the gun. Again, super easy to prove.
Rotation. Does that
Does
that not engage with a field kick?
So if you have a north-south stadium, and many are, if it's oriented that way, and the kicker kicks the ball, depending on how high and how long it's in the air, the rotation of the Earth can have a significant effect on its trajectory towards the goalpost. If you're trying to make a 50-yard field goal, that's far away enough, and the ball is airborne long enough for the rotation of the Earth to deflect it to the right by 1/3 of an inch. Cincinnati Bengals against, I forgot who, was it Seattle Seahawks? In overtime, sudden death kick, and the kick went up, and everybody's heart stops, and no one breathes, and there it tumbles, and it hit the left upright and went in for the win, but kind of barely went in. And then I tweeted, I said, this game was won, assisted by the rotation of the Earth. And that force that makes that happen is the same force that sends hurricanes rotating counterclockwise in the northern hemisphere and clockwise in the southern.
Well, it's just bizarre because snipers have been using the literal curve of the Earth to plan where bullets go. That's
If
how
they
you
want it that
plot
precise.
out.
Oh,
yeah,
yeah,
I mean, you
yeah.
have to. When you shoot at a
Yeah.
mile,
Yeah.
you know, when you're shooting like well out over 1,000 yards, those factors.
All right, one of the things that pops up in every one of our long-range rifle classes is Coriolis effect and spindrift, okay? It's in every ballistic program. It's out there. It's in some manuals. And it's theory, okay? Here's where I'm coming from. I was on several long-range rifle and sniping type web pages where there's interaction between the folks that are on them. And a question came up from a kid that was a brand new Army sniper. He was getting ready to go to sniper school, and he was worried about how he was going to pass this course. So, of course, he put it out there to any Army snipers. Hey, what am I going to get to go through? What do I need to work on? And one of the answers he got really pissed me off. It was, you need to worry about Coriolis and spindrift more than anything else. Now, given the plethora of other information, mathematical equations on range estimation, sight alignment, sight picture, breathing, trigger control, follow through, prepping for the next shot, all these things result in quality accuracy downrange if you do them properly. Coriolis and spindrift are theory, okay? Whether you want to agree to this or not, it's somebody's mathematical theory.
You have to when you shoot at a mile.
So as the bullet leaves the barrel of the gun, the Earth is still rotating, and the bullet is not rotating with the Earth. So the Earth will actually rotate out from underneath of the bullet while it is in flight.
Whether you want to agree to this or not, it's somebody's mathematical theory.
We are all moving with the Earth at 800 miles an hour.
So as the bullet leaves the barrel of the gun, the Earth is still rotating, and the bullet is not rotating with the Earth.
We are all moving with the Earth.
You have to when you shoot at a mile.
You apply the fundamentals of marksmanship. This may have an effect, but I'm back to the wind again. Is it not you calling a bad wind call, or is it spindrift? We don't know. Now, the problem with the standard theory and Rod's theory, or Storm Mountain's theory, is we can't test either side of the coin. We basically need a 1,000-yard indoor range with 100% no wind conditions inside that to prove this fact, or theory, I should say. It's not available to my knowledge. I know of no indoor range with no wind conditions in the country or the world, and I've shot on a bunch of ranges. For that matter, I say apply the fundamentals of marksmanship, dial in your wind properly, which is the big issue, shoot your shot, and adjust off of that. Thanks very much.
Dave just completely removed the Coriolis from this. That bullet, if it was fired, by the way, I don't ever advocate ever firing bullets towards any living thing ever. If any bullet was fired that was below the equator and was traveling to its target, the equator would be spinning faster than the source that was conserving the momentum not spinning at the equator. So something that's not spinning on the equator is spinning slower than the equator for speed. So the bullet would actually be traveling slower than the object. But this is just here pointing out how Dave uses something that is not quite accurate because there is absolutely no Coriolis taken into account at all.
Get back on that moving truck. This time, bring a friend and pass a ball back and forth. You will observe that the ball does not fly off the back of the truck when it leaves your hands. Instead, you will be passing it precisely as you would expect if you were just standing on the ground.
This is an inaccurate comparison because the truck here is going straight at a constant velocity and the Earth rotates, so it has angular velocity. It is considered constantly accelerating. For this to be an accurate representation, the truck needs to be either making a constant turn, such as doing donuts, or the truck needs to be constantly accelerating as it goes straight. However, if this happened, I believe that the results would vary and not align with what Dave is wanting.
Another way of expressing this is that U2 and the ball and the truck constitute an inertial reference frame.
Here is a much more accurate depiction in the heliocentric model of what our solar system is actually doing. Now, where is Kepler's laws in this particular model, Dave? The mathematics for this are not being taken into account.
This graphic is stupid. The blue trails don't exist or mean anything, and the solar system is not a vortex.
So I don't know if Dave knew this or not. I feel like he would. Those blue trails are actually, they're just showing the paths that the planets would orbit around the sun. Because what you have to remember is that the planets spin around the sun, and the sun is also moving. So if you're making a spiral and going in three dimension, it's going to be a vortex. We actually are moving in a vortex. This is a very often used graphic because it's supposed to more accurately show how the Earth and the solar system moves about as it orbits around the galaxy. And then the galaxy itself is also drifting straight. So it is a form of a vortex. You also, I could be wrong here in this instance, but isn't there some sort of issue with like three-body physics or something, gravitational physics for three-body problems? Maybe I could be off there, but this is a depiction of how the Earth is said to be moving, and by the way, none of this motion is measurable.
All the motion happens within a plane, and we see that plane in the sky. It's called the ecliptic, where all the planets live. But more importantly, what you're trying to imply is that because the solar system is moving through the galaxy, this should change all the laws of physics. It doesn't. Here's why. Let's do another experiment. Drop a ball and see how long it takes to hit the ground. Now let's get back on that truck, move at a constant velocity relative to the ground, and do it again. We get the same thing. Now get on a plane and do it again. The plane is moving much faster, but you still get the same result. Each of these is an inertial reference frame. The laws of physics are exactly the same in every inertial reference frame. So the results of this experiment are the same in each of these frames, no matter what speed it is moving relative to something else. That's because all motion is relative to something else. So I'm sorry, it doesn't matter how fast the solar system is moving relative to the center of the Milky Way, or how fast the Milky Way is moving relative to some other galaxy. There is no absolute motion. There is only relative motion.
So what he does here is he shows everything keeping the same trajectory or the same acceleration, so it appears that you can get that relative motion. But the thing is that the Earth is constantly accelerating. The sun is constantly accelerating because they're constantly changing their direction. So it's constant acceleration. So all of these examples that he gives here are null and void. And what he says about there being no absolute motion is very important. This is precisely why he cannot claim to detect motion to the Earth, because everything is relative. You can't detect it if it's relative. Einstein knew of the pendulum and the gyro and still had to come up with relativity, saying that the Michelson-Morley result was null, that there was it was relative, and that you can't detect motion to the Earth.
Okay, let's shift gears and come back down to Earth. You guys have a lot to say here, especially regarding the stars in the night sky.
Because the stars have never changed in all of recorded history, all of millennia. Nothing has ever changed.
False. Take the North Star. Right now, it's Polaris. In the time of the ancient Egyptians, it was another star called Thuban, which is documented. In a few thousand years, it'll be a different one still. The precession is extremely slow. Any thoughts?
He claims here that it's Thuban that is the North Star of the Egyptians, but we can see that it's been Polaris for the last couple thousand years, and stars wouldn't just move in gigantic jumps. It would take time. There would be drift, and we are still using Polaris now. If anything, the websites actually say, actually I just read something about on a site called Starfax that says that they still don't actually know the distance of Polaris from the Earth, between 32 or 320 light years and 420 light years or something like that in the globe model, but they don't know the distance really of it, but they say if anything it's actually getting closer to the pole, that so it is the pole star. It's what we've been using. It's what astrolabes use, and astrolabes go back to very early 6th century AD, and they're still accurate. So we have had Polaris as our star for a long time.
Also, if this was all made up, why make up this part? Why deliberately introduce the problem of the precession of the rotational axis if it's not needed for anything? Then comes this bit about the personal dome.
That's all the stars we can see. And the stars lower to the horizon at the edge of that circle, of a 12,000 diameter circle. So as you move, this dome of stars moves with you, or your dome of vision.
We could deconstruct the absurdity of this idea for 10 hours, but I'll just say one thing. You can use the words perspective and refraction all you want, but that's all conjecture unless you can build a physical model that predicts the position in the sky of any star for any person anywhere in the world. Do that, and then we'll talk.
So with regards to the personal sky dome, it's for each person. Each person will have a unique sky from their perspective, which will render itself as a dome. The claim is not that each person has their own unique sky. We all have one common sky, shared reality, and then depending on where you are standing, it's the same on both models. Wherever you're standing determines what stars are above your head. So there are things that do let you make predictions, things like an astrolabe, a planisphere, and then ancient cultures were also able to chart stars to know when things were rising and setting, sun, moon, and stars. And they did it all with the view that the Earth was centric and that it was planar and non-moving.
Let's take a look at who are these Babylonians who invented solar cycle. Babylonians are descendants of Sumeria, the first modern human civilization 6,000 years ago, earlier than ancient Egypt. It's located in Mesopotamia, or modern-day Syria and Iraq, the birthplace of Abraham, the father of three religions, Hebrew, Christian, and Islam. It's the cradle of civilization. Their inventions and achievements are still used today. Astronomy, irrigation, architecture, mathematics, politics, code of law, urban planning, almost everything except internet and cable TV. They are very smart people. Their alphabets, cuneiform, consist of 400 characters, not 26 characters ABCD like us. Their numeral system is sexagesimal or base 60, not base 10 like us. Sexagesimal is very good for counting big numbers and small numbers, still used today for measuring time, angles, and geographic coordinates. They are the one who invented 360 degrees in a circle. Do you know why there are 660 degrees in a circle? It's the average days of the sun and the moon circling the earth in a year. The sun is circling the earth in 365.2425 days, and the moon is circling the earth in 354.3829 days. Add those numbers, you will get 719.61 days. So the average of lunar and solar days in a year is 359.8 days, rounding to 360 days. That's where the Babylonians got the idea of 360 degrees in a circle and got sexagesimal numeric system base 60. It's really
Staying on the Earth, let's check out this bizarre tangent you took into ecology.
At 65 degrees north latitude, Iceland thrives with 870 native plant species and abundant animal life. Compare this to Georgia Island, which, despite being a whole 11 degrees closer to the equator than Iceland, at 54 degrees south latitude, is nearly devoid of any ecoculture, having only a measly 18 native plant species and virtually no animal life.
There are no animals on this one island, therefore the Earth. Got it. Sorry guys, there's a lot more to ecology and climate than just latitude. Again, easy to prove. What's the hottest place on Earth? Death Valley, California. Notice that it is nowhere near the equator. Take a look at the distribution of biomes around the world. There is some correlation with latitude, but it's not perfect. Pick a latitude and see a desert over here, a rainforest over there, and all sorts of things. And finally, the thing with the animals is just stupid. The distribution of animal species is subject to an incredible set of variables that are irrelevant to this discussion. All you can really assume is that the continent of Antarctica should be super cold. And yeah, it is. It's right on the South Pole. As it happens, you had lots to say about Antarctica as well, namely because it's the super secret edge base fortress whatever, and no one can go there.
Now, what you have to understand is this is a naval ice patrol ship. It's also an icebreaker. It can get through places no other ship can go, and even if it tried, it would be crushed into a million pieces. Okay? This ship is designed to cut through the ice and come and find you. It has a sensor on it. You also have buoys on the ocean that have been there for a long time. I think maybe even all the way back to maybe World War II. But anyways, check this out. Even if you can go under the radar of the Navy, they have these buoys that set off signals that will notify that icebreaker, and he will come and capture you quicker than anybody else can get there. That's his job. That's what that ship's made to do. It can break through that ice and find you very, very quickly. There are not any other Navy battleships that can do that. We got some tough battleships, but only a few ships hide behind this ice and wait for you to get there. Now check this out. Here is a Google diagram of how it works, but you got to cut out the satellite because those aren't real. It's just simple towers. The buoys are like towers on the ocean because the ocean is. They send a signal to each one. And as soon as that signal goes off, when the waves get just a little bit rough, they know exactly where you are. And if you've ever seen a Navy radar, you would know that. Look at it. It shows the whole Earth. Now, I'm going to show you guys something. They even show you how they can find you without using radar. They hit it in the movie. Check this out.
Pearl Harbor here. We're approximately here. And they, whatever they are somewhere in the middle. We're trapped out here. What we know right now is we can't target them unless we have a plain line of sight. Without radar, we have no way to track them, correct?
Correct.
Okay, so they can't see us and we can't see them. And we have no way to hit them from a safe distance.
There is a way.
A way?
A way of seeing them without seeing them.
You're going to reference Art of War right now, aren't you? What are we supposed to do? Fight the enemy where they aren't? Move like water?
My way is much more simple. We've been doing it to America for 20 years. Water displacement.
How do you track water displacement?
Tsunami buoys.
Tsunami buoys.
You have them surrounding your islands, transmitting displacement data. We hack into their transmissions, form a grid.
You can't track anything without radar.
I don't need radar. Just the radio frequencies. Turn off Aegis radar, please.
Who is this guy?
Chief Moore. Sir.
Secure spy.
Secure spy, sir. Display no data.
No idea.
Yes, correct.
You heard him. Display no data.
hell is that?
It's a buoy. If it gets hit by a wave, it transmits a signal.
Bring up chart plot.
Chart plot. Bring it up.
So we can track without radar. We would practice it as a contingency plan.
Dirty, cheap, sneaky.
Rough world.
I like it. Towers, they give off a signal, people. So no matter where you are on that ocean, they know exactly where you are. Now what you are looking at here are the logos of the 5 government agencies that control our so-called globe, our so-called spinning ball. Now before we identify the logos, let's have a look at this map that hangs on my living room wall. And this map is the Gleason World Map from 1892, number 6 from the Boston Public Library. Okay, and as you can see here, it was published in the Buffalo Electrotype Engraving Company in New York. All right, and as you can see here, it's scientifically and practically correct as it is. Okay, now back to the logos. Here we have the International Maritime Organization, which basically controls our waterways, all of our waterways, how far out we can go into the ocean, territorial boundaries. Okay, so now let's have a deep look into their logo. Now, isn't it awful funny that the people who control how far we can go out in the water have a map with an ice wall as their logo? Okay, anyways, here we go. The International Civil Aviation Organization. Now, this is the government agency that controls our airways, how far we can fly and where we can fly. And once you fly out too far south, they're going to turn you around. But anyways, let's check out their logo. Okay, as you can see here, hidden in their logo, the agency that controls our airways has the map with the ice wall around it, hidden right in it. Okay, now here we have the World Meteorological Organization, which basically they control all the mainstream media information we get about storms, hurricanes, and all that good stuff. So, anyways, let's check out what's hidden in their logo. Okay, control all the militaries in the world, all of the treaties that are signed in the world. These people control this. And I think it's awful funny that if you look in their flag, they have in their flag. And if you go into their General Assembly Hall where they hold all their meetings and sign all their treaties, guess what's on the wall right up above them? Now, this all could be just coincidence, but I don't think so. If you look at any map before 1958, it's with an ice wall around it. And all the government agencies that control our airways and our waterways have the map with the ice wall in their logo. Okay? Now, if you were to try to get in a private plane or on a private boat and try to get too far south to try to find this ice wall, here's what's going to happen. The Navy's going to show up in a battleship or a jet fighter and turn you around and escort you out of the area. Now, let's watch and see what happens when a private boat or a private jet gets too far south. 80 degrees south, that is. Now, these guys are nowhere near the ice wall, but here's what happens when you get too far south.
Hey, it's a Navy destroyer. He will yield. He'd be thinking, that cheeky better not cross my bow. Stop, Josh. They take it seriously. What did they say? You got to yield. You can't just fucking. They think you're going to charge them.
We don't know for sure, but they did say something. No, they did.
They,
I thought I heard.
They come back last fall. Yeah, fucking talk to them.
Actually going around. He's turning. Stop. He's turning. He is actually turning.
You said about the ship yesterday.
No, he is turning. Fucking hell, what have we done now? It's turning, Josh. Just sit still.
He's slowed down, has he?
Yeah, he's really slowed down. No, then we're in trouble.
What for?
It's coming to us. He's got the shits because.
This is Washington over, channel 16 over.
16.
Yeah, we got you, mate. It's bad boys.
Gotta go channel 16. No.
You are in a maritime exclusion area. Please report your intentions.
We're heading to the shelf to go.
Just say we're heading out fishing. Heading out fishing. No, we're just heading out fishing. Get the dinghies out, boys.
Going that way.
We're just traversing. But they're not
Is there a helicopter coming at us now? Are we landing? I don't know. What
just travel. Just go.
Just go.
You sent out the chopper. That's a drone. Is it? That's unreal.
Getting set up a demo today with this Cessna and the Air National Guard. I'm going to be inside of this Cessna, and we're going to be going rogue. We're going to fly into that no-fly zone, and we're going to see how the Air National Guard does it. They scramble the fighter jets to come
Take off. We're off.
flying for miles and miles until...
Okay, we've just entered the no-fly zone now.
Our pilots aren't talking to air traffic control, ignoring their calls to reach them. That triggers an alarm at the Air National Guard base. These fighter pilots scrambling to their jets. They're on alert and ready to take action 24 hours a day. Today, racing to their F-16s, suiting up, climbing on board, and rushing to the runway. Taking off to intercept our rogue Cessna. Reaching the target in just minutes. This is the view from the F-16. That's my Cessna right there.
Intimidating as you would think it would be. Look at that fighter jet. He's right off our wing.
Another F-16 swooping in on the right, calling us on aviation frequencies.
You have been intercepted. If you hear this transmission, acknowledge the radio call and rock your wings.
He wants us to identify ourselves. We're a rogue aircraft, remember, for this demonstration, so we're not going to respond at all and see what this fighter jet.
You are ordered to turn to the northwest.
The fighter jet giving us one last warning. After all of this, the pilots still won't listen. The plane won't leave the airspace. Will you shoot them down?
If required, we'll execute the rules of engagement per the commander of the North American Aerospace Defense Command. And yes, we would do that.
Shoot the plane down.
If it meets the rules of engagement, yes, we would, to defend the airspace.
Entering restricted airspace. You are ordered to turn west immediately. If you do not follow these instructions, you may be fired upon.
There's so few of them, and all of them, by the way, are Masons, right? Or royal family or something like that. But the average Joe can't go down there.
Sure, only Freemasons can go there. Or all of these people. Guys, just Google Antarctica cruise. Literally anyone can go there, and they do so every day.
And so what I did was I wanted to go ahead and look into booking myself a little cruise.
But what they don't do is patrol the entire Antarctica, because anybody can go there. And what I find utterly stupid is the fact that there's literally tens of thousands of people moving over Antarctica every single week.
So the first thing I will do is show you why not everyone can go there. And the second thing is I don't usually call people liars, so I'm just going to ask for your evidence in claiming that tens of thousands of people fly across Antarctica every week. That's what you said. So show me the proof of flying across Antarctica. If you look up any flight charts, they don't fly across the continent at all. So show your evidence on that one. On the screen now, you'll see why not everyone can go to Antarctica, because not everyone has between $40,000 and $75,000 for a 5 or 6 day trip. So I'm on this site. It's called polarcruises.com. I'm looking at all their little deals, and it looks like a scam to me because you don't need that kind of money for a trip to Antarctica. So anybody charging you $45,000 to $75,000 for a 5-day trip where you're staying in a tent and peeing in a bucket, there's a problem there. So I also looked up and tried to find out how many people fit on one of these planes, and they usually have 66 people on the plane. And if you multiply that by the ticket price of $40,000, you get about $3 million. So this is where I start to smell scam. To make that kind of money is not necessary on upcharging that much. So the first thing I did was run the site through Whoisology. Really cool site if you're looking for the owner of a site or IP information, registrar information. And when I found it, I got some other interesting news. He owns over 150 other related domains besides polarcruises.com. In fact, look at all these. This travel agency or scam center have all the Antarctic and Arctic trips in their hands. You must go through them. So that was just more fuel to my fire. Sites like penguincruise.com, Antarctica Cruise, Antarctica Tour, Antarctica Trip, Polar Bear Cruises, Antarctic Voyage, Antarctic Journey, Antarctica Journeys, Arctic Voyages, Antarctic Tour, Antarctic Vacations with a hyphen, Antarctic Trip, Antarctic Adventures, Antarctica Cruise. So, as you can see, he definitely has the corner on the market. Next up was to find out, are they even in business, or is it an all-out scam? So I searched for reviews on other sites. Obviously not their own site where they could make whatever review they want, but on other sites. First review I find is the review right here. Polar Cruises reviews. Maybe this is too late to help you, but here's our experience with Polar Cruises. They were very helpful at the beginning when we first called about a cruise. They told us there was only one cabin left on the cruise that we were interested in, and that there was a waiting list for it, which upon looking back doesn't make sense. Why sell it to us if there's a waiting list already? But we went ahead, paid the deposit, and wired the balance. 15 days before departure of the cruise, an unexpected medical issue emerged, and we couldn't make the cruise. We had no trip cancellation insurance, big mistake, and immediately called Polar Cruises. After some delay, Polar Cruises told us that Oceanwide Expeditions, the ship's operator, would allow a name change for the cabin, that is, find someone else to take the cabin, but we had just 24 hours to do this, and that if we couldn't find anyone, to call them immediately to cancel our booking, but with zero refund. We asked if they could help us, given the extensive contacts they have, but they didn't even reply to this appeal and did absolutely nothing to help. We then called Oceanwide Expeditions and said 24 hours was too little, and to do anything. After this call, Polar Cruises then informed us that we had a few more days to do the name change. One question that still remains is why Polar Cruises had given us a 24-hour deadline if we were not going to get any refund from Polar Cruises or Oceanwide anyway. In sum, our experience with Polar Cruises was not a good one, and I would never recommend them. So you're talking about probably the theft of $25,000. Just a guess right there. Who knows how much the trip was for? Could have been $70,000, could have been $10,000. I don't know, but I was on the right track. There's a problem with taking a cruise down in Antarctica. Now, I hope you are ready for the story to get a little bit juicy. Thanks for holding on so far, because it's about to get real interesting. So, in looking at the page here that lists the employees, I'd already looked up Jim, couldn't find anything. He's the one who owns all the domains. I looked up Sharon, couldn't find much. Again, both Jim and Sharon have very non-unique names. But Chuck and his wife, Lynn, were easy to find. Here you're looking at Chuck Cross. He is a Antarctic polar expedition leader, so it says. So is his wife. But they only have one photo of themselves all online. So, I mean, if you can search Google, I did here in a second, you'll see it on the screen. And that even putting her name and Bend, Oregon, where they supposedly live, turns up just that one photo and only articles that look like they come from their site or are in regards to them being travel agents. You can see here, just that one picture up at the top. So that left me with one other person. And I looked her up, and I always thank my lucky stars when I see somebody with a unique name. They're usually easy to find online. Her name is Nina Spinrad. So here it talks about her being an outdoor lover. And so I began to search Spinrad, Nina, and I get a ton of results for a Dr. Richard W. Spinrad. Who is he? Well, he was named in 2014 as the NOAA Chief Scientist by Barack Obama. Then I see Mr. Spinrad was the president of research at Oregon State before his appointment as head of the National Oceanic and Atmospheric Research Center. And, of course, we know that this travel agency is based in Oregon. So prior to that, he was the research director for the U.S. Navy. He also, as he is a direct and permanent representative to the United Nations Intercontinental Oceanographic Commission. He's been given awards from Bush and Obama, and now there's no way that this Nina is related to him, right? So I found a obituary for a Gene Thompson. And if you're ever looking for relationships, the best place to go is obituary, since it spells it right out for you. And in Gene Thompson's obituary, he was survived by his daughter, Elena, and her husband, Dr. Richard Spinrad, and their son, Gary, and his wife, Nina Spinrad. So for those of you following along, we now have one company who owns all the domains for Arctic and Antarctic trips. It has 5 employees. One of them is the daughter-in-law of the head honcho and President Barack Obama's selection for chief scientist for the NOAA.
Sure, only to certain spots, but Antarctica is a huge, frozen, barren wasteland. No tourist would want to traverse it. Even if you insist that no one is allowed below a certain parallel, what's stopping you from getting in a ship and sailing around the world directly on that parallel? Time it and compare it to what a round Earth expects. That sounds like a pretty good experiment. Let's move on to gravity. This one's a big problem for you guys, because if the Earth isn't round, then gravity doesn't make any sense, and there's no reason for objects to fall towards the ground. Let's see what you've come up with.
You know, what goes up must come down is absolutely a thing here in reality. Nobody's arguing that. But as you said, the cause of that on the spinning ball Earth theory is the mass of the Earth warping physical space and non-physical time.
Space-time, one thing.
So I'm really not sure how you can bend time, but maybe that's just because Here's the thing. First of all, you can't demonstrate in reality that mass attracts mass. There's no sort of experiment or data or test that you can do.
False. This was done with the Cavendish experiment all the way back in the 18th century, long before NASA and pals.
Henry Cavendish, even though he was part of the rich dukes of Devonshire, that family, and incredibly rich, he went to Cambridge to study natural sciences, or natural philosophy as it's called. But he had a very curious condition in that he could hardly talk to anybody. So when it came to his Viva exam after 3 years of study, he fled Cambridge rather than sit in front of the examiners because he was petrified of them. But he was one of the most brilliant scientists of that 18th century in both chemistry and physics. For chemistry, he's noted because he analysed gases in the air. He discovered there was hydrogen, which is a huge component of the universe. He called it inflammable air. So he put some acids in a container, dropped some metal like zinc into hydrochloric acid, and got the gas to come off. And then to show it was inflammable, you could set light to it, he breathed it in and blew it into a candle. Now, do not do this at home, because it blew up and took all the hairs off his face. He invented the idea of electric potential before everybody else, and used to set electric currents through his body to work out the voltage was proportional to current, and he measured the current by the degree of agony he felt with the electrical current. This is not the normal sort of person. He couldn't talk to most people. He couldn't talk to women at all. His housekeeper would get a recipe for something or other, and he'd say, no, lamb tonight, leg of lamb, and leave a note for her. He wouldn't say it, he'd write it. He would dine in the evening with his friends, and he would talk to them, but if he didn't know somebody, and you wanted to ask him a question, apparently you had to go to the Royal Society, and he would be in the room, and you'd address the room this question about physics, and you postulate, and if he felt in the mood, he would reply to the room. He was a very strange man, and yet he's absolutely wonderful. He invented hydrogen. People went up in hydrogen balloons and could see the world from through that perspective. He did most of the experiments quietly on his own, keeping his notebooks, and it was only after his death and a persuasive campaign by Clerk Maxwell, the famous Maxwell of Maxwell's equations from Cambridge University, that he actually got the notebooks from the estate of the Dukes of Devonshire and discovered after the event that Cavendish had discovered the unit of capacitance, discovered dielectric constants, he discovered Dalton's law of partial pressures, he discovered or written about Coulomb's law, all before these guys had done it and just left it unpublished in his notebooks. Towards the end of his life, he did a crucial experiment, which is represented by these lead balls. he lived in Clapham Common, which is nowadays a very poor part of London, but there it was quite fashionable. And he built his own place. His library he built somewhere else because he didn't want anybody borrowing his books from his house. Otherwise, he would have to ask the book back and he didn't want to talk to them. So his library was 4 miles away. At the back of it, he had a big garden shed, which might seem like the size of my house. And in it, he had 2 lead balls, like this, suspended from the ceiling. Only this is not to scale. This is, lead balls. Now, the real problem is that he wanted to measure the attraction between 2 objects due to gravity. In other words, there's a gravitational attraction between you and me, or between me and this lead ball. So he had to be a long way away to look at the experiment, otherwise he'd interfere with it. So he had an aperture, a place where he could look through, and he put a telescope out there, and he stood outside in all weathers, and he was in his 60s doing this, staring through the window to take his measurements over a year. There's another set of lead balls inside there. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated. And then right in the middle there's a bit of glass, there's a mirror which should be suspended from a torsion wire. So you'd set it up like this in his shed, and you put it like that, and this lead ball would attract that lead ball, and this lead ball would attract this one. And so it would be pushed a little bit this way and twist the wire, and that would be pushed a little bit that way. And the wire would twist, and as the wire twists, the mirror, which is dangling in there, would twist a little bit, and light which comes in would be reflected off at a slightly different angle. And all he had to do was measure the angle. He then had to move it the other way round. Oh, he didn't move this bit. He moved the lead balls round so that you had an equal and opposite effect on the other side. So instead of you'd have that configuration. He had this is a very complicated technical thing for the time. 18th century we're talking about, and he put that way round, and then it was pushed the other way, and you could then see the displacement. Moreover, you could measure the period of oscillation of this, and from that get all the properties of the wire, the torsional constant. And that enabled him to measure big G, the gravitational constant, to an accuracy of 1%. And nobody improved on that for 100 years. He didn't describe it as that. He described it as though he was weighing the Earth. He was calculating the mass of the Earth, so that when you're attracted to the Earth through gravity, it's the product of the mass of the Earth, this big gravitational constant, divided by r squared, the radius of the Earth squared, which we normally know as acceleration due to gravity. And that quantity is essentially big G, and he measured it. And nobody could do a clever experiment. So he's a father of physics, experimental physics, some of the ideas of theoretical physics, and a lot of chemistry.
If you've never seen it or just need a quick review, here's the equation that describes Newton's law of gravitational force. The force of gravity 2 objects will both experience is a product of the 2 objects' masses, and will be inversely proportional to the square of their distance apart. When it comes to the strength of gravity, mass matters and closeness matters. So now that that's been reviewed, well, that's what you unanimously reject. They feel that Newton's law of gravitation is a lie, that it cannot be observed. You would not be able to demonstrate in a at-home or classroom setup mass attracting mass. Well, here's where the Cavendish experiment comes in. The gist of it is to have 2 masses hung in a way that is referred to as a torsion balance. The masses are hung in a way that allows them to be balanced, but also allows the entire balance to be relatively free to rotate. The 2 hanging masses then are never motionless in their little bit of rotation, but efforts are still made to minimize what could disturb their motion. When they are motionless enough, high-density masses should, in theory, be able to be placed close enough to the hanging masses to show an obvious gravitational force of attraction. I was significantly impressed with 2 videos by a fellow science teacher, Andrew Bennett. He has 2 very well-done, well-explained videos on the Cavendish experiment, and he shows all the steps involved, so that way anybody who wished to could reproduce his experiment. I think that those 2 videos together already showcase very effective, understandable, empirical evidence of gravitational attraction. But Andrew Bennett inspired me. For his experiment, he used bowling balls. I knew that I had access to lead bricks. Used to make movable radiation-blocking walls, I knew the educational outreach of a facility that uses them. And I was able then to get 2 on loan for my Cavendish experiment. I reasoned that if bowling ball material was already enough to get convincing results of gravitational attraction, then lead bricks, the effects would only be more pronounced. Newton's law of gravity qualitatively predicts that if we have a Cavendish setup that is sensitive enough and use high density masses, we should be able to observe mass attracting mass. Let's get into the classroom. Welcome to my classroom. And what I have behind me here is my attempt to reproduce the Cavendish experiment. For my setup, what I have are 2 meter sticks which have been taped together. And on either end of these 2 meter sticks, held there with some paper clips, are 2 1 kilogram masses on each end. Now this meter stick is being hung by a copper wire which runs all the way up to the top of this very large piece of wood, which I have separated out and have supported up on lab tables with some physical science and AP chemistry textbooks. I'm here on a Sunday, and I've let this hang here since Friday when I left the building. It has been relatively undisturbed, has been relatively undisturbed, has been relatively undisturbed, has been relatively undisturbed. During a school day, and even after students have left, there's so many people opening and closing doors in the building and moving through the hallways that plenty of air currents are produced. And this experiment is quite sensitive to air currents, quite sensitive to air currents, quite sensitive to air currents, quite sensitive to air currents. And that's also why, as I talk about this, I'm showing you plenty of footage with a clock in the background, so that way you can see by just sliding that YouTube bar how much or how little movement is actually happening. And before we do the experiment, we're going to get plenty of footage too as to the lack of movement, as to the lack of movement, as to the lack of movement prior to adding the masses, compared to the movement that we have after adding the masses. And so for the masses, this is a lead brick. And I'll be massing this in a little bit here so you can see just how heavy we're talking about. But 25, 30 pounds, somewhere around there, I'm just guessing. Because of the large amount of mass, but also in a smaller volume, I should be able to get these bricks pretty close to those weights, those masses that are hanging there, and then the results should be very obvious. So before we begin, let's check out how heavy these bricks are. I turned off and on the scale, so that way now it is re-zeroed out, so it's not even registering the mass of these plastic bags. Let's put a lead brick in. I've always done this with 2 hands. I've never been like holding it while I do it. I'll get this all on footage, of course. Oh. Okay, and it's holding. And we're at about 12.03 kilograms. You get a workout doing this. So, that's about a little bit over 26 pounds, but not 27 pounds yet, if my mental math is correct. When it comes to the Cavendish experiment, it's not just about how much mass you use, it's also about how much volume it's taking up. If you had something really large and massive like a car, well, it also takes up a whole lot of volume. And when it comes to gravitational effects, it's not just about the mass, it's also about the distance squared between the 2 objects. So yes, you want something very massive, but you also want it to take up not too much space, so that way you can get the hanging masses over there on the Cavendish experiment to be able to get close to the center of mass of your objects. Without further ado, the Cavendish experiment. There you have it, the Cavendish experiment, recreated in a classroom setting. Now I'm going to pack up my stuff and head home. I'll meet you there and we'll talk about it. From the downward angle, we can see the torsion balance's amplitude. This is the noise in the experiment. So a torsion balance is always going to have some amount of noise, some amount of rotation amplitude that comes with its setup, due to imperfections in conditions, imperfections in the setup, due to imperfections in conditions, imperfections in the setup, due to imperfections in conditions, imperfections in the setup.
This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated.
In getting the first preliminary motion of our torsion balance, we can see how far counterclockwise and how far clockwise it was normally moving. From the left-hand side of the torsion balance, you could say the lowermost limit and the uppermost limit. That represents the amplitude, the noise in our experiment. When the lead bricks are put in place, the torsion balance was already moving counterclockwise. Yet, notice it does not reach the previous maximum counterclockwise position. If there was no attraction to the lead bricks, then adding the lead bricks should not have prevented in any way, shape, or form the torsion balance from just continuing on to that maximum counterclockwise position. Already moving counterclockwise, when the lead bricks are placed, the torsion balance slows down, doesn't reach the previous maximum counterclockwise position, slows down and changes direction, and begins then moving towards the lead bricks. The only way in physics that this can be occurring is that the torsion balance is being accelerated in the clockwise direction. An acceleration on a mass is due to a force. The lead bricks are exhibiting a force of attraction on the masses of the torsion balance. This is the gravitational effect of the lead bricks disrupting the previous equilibrium. Continue to watch though, and the effect is even more obvious and pronounced. In high speeds, once the very dense lead bricks are brought in, the masses of the torsion balance are observed to be physically drawn to them. The faster we play back the footage, the more blatantly obvious it is. From the side view, the evidence is again compelling. This is an observable force of attraction between objects. This is gravitational force. Beautiful, observable, empirical, gravitational force. Thank you for joining me on this episode of...
Oh goodness, what was his name? The stupid balls in the shed experiment or whatever.
Cavendish.
Yeah, the Cavendish experiment certainly notwithstanding. But there's no evidence to suggest that mass attracts mass.
All you did was name the experiment that does the thing you're asking for and then proceed to say nothing about it.
So I actually wanted to hop in here real quick and say something. I actually did reply to this guy's video, this teacher's video, and I wanted to read what I said and then kind of add a little bit more to it, just to give a little bit more depth. So I do have to change. I did say the F blank blank T Earth word, so I have to blank that, or I'll change it. So one of the reasons, this is the comment that I put, one of the reasons biblical earthers say this experiment is unrepeatable is that originally Cavendish claimed his torsion bar was stable. This one was moving. There is no way to determine if there was air current, which there likely was, as schools have vents and even doors with a gap on the bottom. Can you recreate this in a vacuum? And placing bricks on one side could mean that you place them on the tendency side. You said that you would have to have waited another week for the bar to settle. Why? It wasn't settled in the first place. You said that you would have to have waited another week for the bar to settle. Why? It wasn't settled in the first place. And if you put the blocks on the other side, the sway would have slowly pulled back to the center point, then through it to pull the bar to the opposite side, because gravity would have been in continuous effect. So basically what I was talking about here is if you have this weight that's being pulled to the block, if you pick that block up and moved it to the other side, would it pull back despite the tendency being on that side? And then you can interpret it still. Is it gravity, or is it the wind current now not being blocked on the one side but instead on the opposite side? There is something to if you do think about this Cavendish experiment, or how this gentleman has created it here, you see that the first time that the weight hits the block, that it actually bounces off. Now imagine this is pre-stellar, pre-galaxy. Imagine these first molecules of very heated hydrogen, helium, and lithium. So tremendous energy. Imagine these small particles where gravity is already basically not able to be effective. It's all strong and weak force and electromagnetic force. If you have these particles that are colliding and bouncing off each other, they're never going to get a chance to conglomerate together and to clump up and become this mass that can attract more, because anything that hits apparently bounces off the first time. But it has to actually stick. It has to hold and grow in mass. You can't do that if things are bouncing off and flying off away forever in another direction. So there are some issues in this experiment because it can be wind, because it can be gravity. It actually should be done in a vacuum. And I have never seen this experiment. I've looked. I've not seen it performed in a vacuum anywhere. But this could help to eliminate wind, as he admitted. And it basically should pull through all the way if you set it on the other side. Another thing you could try is, what if you put both bricks on the same side, and instead of spinning or rotating the torsion bar around the axis of the wire, it would instead actually pull the whole stick and kind of move the wire as well from plumb and start pulling it to the side. So there are other things you could do, but again, wind or gravity, which one is it? You can kind of explain it either way.
Physics undergrads do this experiment all over the world all the time. If you think it's invalid, explain why.
But of course, Professor Dave will come back and say, "Oh, it's done every day in colleges everywhere." Yeah, okay, whatever. And it certainly is not done the way that Cavendish did it.
Looks pretty similar to me. Also, why should it matter? Your mantra is do your own research. You seem to think that science students are just told what to believe. Shouldn't you be encouraging them to do these classic experiments for themselves so that they can verify, what was it again?
Do you guys know what the idea behind Cavendish was, right? To measure the mass
of the Earth, right?
Wrong. The purpose of the Cavendish experiment was to calculate the gravitational constant, g. We knew these two masses and the distance between them, so measuring the force of attraction allowed us to calculate g. Once we knew g, we were then able to calculate the mass of the Earth, but that's just an application of this knowledge. So really all we have here is you guys talking incorrectly about an experiment and then offering no basis whatsoever for why you think it's invalid. Let's see what other problems you have with gravity.
And if you assume that the Earth is a spinning ball, what you would expect is that objects that are on the surface of the spinning ball would tend to be propelled away from the center due to centrifugal force. And so gravity is a necessity in the ball Earth theory to counteract that force and assure that objects are stuck to the sides of the spinning sphere.
Wow, an actual legitimate question. Yes, there is a centrifugal force due to Earth's rotation. It's quite easy to calculate. Let's look at this force at the equator, where it's greatest. In general, F equals ma, and for this force, F equals mv squared over r. So let's solve for this acceleration term, plugging in velocity and the radius of the Earth. And that's the value. As you can see, acceleration due to gravity is much bigger, so we don't have to worry about flying away. But anyway, attacking gravity isn't going to help you much because you still need to explain why things fall down in your model.
So things fall because things want to be at rest, at their lowest potential energy, at their lowest resting energy. So if you have an object that is heavier than if it's denser than the medium around it, so like a rock in the air, it's going to fall. Because it is seeking its lowest potential resting energy, which is low. It takes less energy for it to be lower than it does for it to be higher in elevation. So it seeks this lowest resting energy at a constant at 9.8 meters per second per second. Just like if you have an object that is lighter than the medium around it, say like a balloon in air, it's going to go up and seek its lowest potential resting energy, which is above. And so it will seek this at a constant, and it will get to its equilibrium as far as its density is concerned, and it will stay in that area and hover. You can see objects that do hover when they are at equilibrium with the buoyant force or with density. And it would actually require more energy for, say you dropped something into a liquid into a medium and it found its equilibrium point, for it to actually go down into a more dense layer beneath it, it would require energy.
Earthers cite terms like density and buoyancy, which is beyond ignorant, since those are really just saying gravity again.
Density and buoyancy are not gravity. Gravity would be like matter-to-matter attraction, as Walter Lewin said, which is only really showable on like a planetary scale. Density is mass over volume. It has nothing to do with G. And buoyancy, we do have an equation that uses G, but buoyant force, it could have another equation. If we want to call the force of something going up or down buoyancy, well, then it has another equation and probably has something to do with density, which involves no G whatsoever.
Denser objects experience a stronger gravitational attraction. If you take away gravity, there is nothing about density that is relevant to this issue. It remains that any downward acceleration will require a downward force. You seem to realize at least this, so which force did you settle on?
Correct me if I'm wrong, Bob, but this is what I believe. This is a bit of conjecture, but it makes a lot of sense to me that in order for density and buoyancy to dictate what is going to go up and what is going to go down, you do have to have a tendency for higher density objects to fall and relatively lower density objects, liquids and gases, to rise. And it really does seem feasible that downward tendency of higher density objects is the static electric charge of the Earth. That is measurable. There's no theory behind that. I think it's 100 volts per meter in altitude of static electric charge. And so there is definitely a feasible explanation for what goes up must come down.
Wonderful! Electromagnetism, a real force. And your favorite force to cite when you can't account for something. Just as with the Coriolis effect, you don't actually explain anything. You just say electromagnetism and leave it at that. Sorry guys, that's not going to cut it. We need math. We need predictions. We need demonstrations. Materials can be paramagnetic or diamagnetic or ferromagnetic. Shouldn't these interact with this force differently and fall at different rates? What about neutral particles versus charged particles? What about the value of the acceleration we observe for falling bodies, 9.8 meters per second squared? Isn't there some math you can do to derive that? Let's see where you take this.
Which did a piece on spider ballooning and proving that spider ballooning does not take place by air currents blowing the silk around, but rather the spider is able to change the electrostatic bias of the silk strand that they are casting and then are essentially acting as an anti-gravitational device.
So a spider does a thing, therefore gravity is electromagnetism. Got it.
The spider does something and it's considered electromagnetic. It's not considered anti-gravity. It's considered electromagnetic because electromagnetism is the dominant force. It's what rules this Earth. This Earth is governed by electromagnetic forces primarily. So this spider is using the primary field that is surrounding the Earth. Has nothing to do with gravity. Nothing does.
Sorry, your spider anecdote isn't going to cut it. What else you got? Well, you flashed this graphic for a while, so let's freeze it and take a look. Ooh, little dipoles. Well, being chemistry inclined, this looks to me just like the intermolecular force known as dispersion. This is already well understood and does occur between all atoms and molecules, and it is attractive. But sorry, this can't explain gravity. If these are attractive interactions between these particles, this arrow on the left pointing down can just as well point up, and this graphic is meaningless. Gravity is the only way to explain the motion we see on Earth. But of course, you say...
But again, it's all horse manure because gravity is neither caused by mass attracting mass, nor is it caused by space and time bending into pockets and then having things fall into it.
Yes, gravity is both of those things. All mass warps space-time, therefore all mass attracts all other mass. If you can't understand that, that's not my problem.
We've gone over a little bit here how gravity is not needed. You can use relative density, and there are electromagnetic phenomena as well, and this explains how things move up or down, especially things that have a charge, that fall at different rates of speed or anything like that. And then the other thing that he mentions here is space-time and gravity being able to bend time and space. Here's the thing about that. First off, you're assuming time is the fourth dimension. If you really think about when we're shown like a 4D cube, which also isn't time, it's always a 3D object within a 3D object. It's 3D. They're just trying to trick you and tell you it's 4D. Fourth dimension, we don't know if it's time, and why would it be logically? Dimensions are spatial. The first dimension, height, second dimension, length, third dimension, width. This gives you your X, Y, and Z axis. Now the fourth dimension is what? It's not space. Now it's time. So if I hand you a meter stick, how many seconds did I just give you? If they're connected, just calculate that out for me, because if that can't be solved by your dilemma of having time as the fourth dimension, then that's not my problem. I don't know why if he's a teacher, he should be trying to educate people. I really do believe we should always be trying to be honest with one another and give each other forthright, accurate information to the best of our knowledge. So time is not connected to space, to dimensions, or anything like that. If there are more than 3 dimensions, they would more than likely be dimensional, or spatial, not temporal. And we basically have no way to prove it. That's why they can only show us a 3D shape and say, ooh, look, it's actually 4D. It's a 4D tesseract cube. When really it's just a cube within a cube. And show 4D if you're going to show 4D. Don't show me a 3D cross section, because you're showing me 3D and telling me it's 4D. And yeah, it's not time. So this is kind of also irrelevant to the fact that the Earth is still and tests and is empirically planar over water, over long distances, longer than should be.
Is that you so thoroughly don't understand gravity that you decide to show me an entire PBS Studios clip that presents some physics in an oversimplified manner to insist that this fake upwards acceleration vector is somehow a massive scandal. Now, you say you don't believe this, and that's fine, but you probably should, because it's the only way you're going to get stuff to stick to the ground.
This is some sort of an absurdity. He's literally telling people to believe in a false model that is a misrepresentation if they are going to choose to subscribe to a biblical Earth. Despite that, biblical Earth is actually at a strong point, a well-held position, because all of our tests that use mechanical objects like a gyro show no motion. When you rule out any etheric or managerial type of motion or influence, electric or magnetic or anything, and you're left with strictly mechanical, you get no motion. This is exactly what Einstein was talking about, and this is what's needed for relativity. It appears like we're not moving because we're not moving. Relativity says it just happens to appear like we're not moving, but we are. So this is telling someone to believe that the earth is moving. That also invalidates biblical scripture. If the earth were accelerating upward, and this would have other easy pitfalls that this type of a model would fall into. And so it's just, wow, to tell someone to fall for a straw man is incredible. That's some sort of processing that I just can't think on that type of stuff. Like, trying to educate people and you tell people to deliberately go for a straw man. Huh.
Falling objects accelerate towards the ground at 9.8 meters per second squared. That's an indisputable observation. If you can't get that through a force pulling things down, then you could get that by accelerating the surface up. And actually, that would take care of it. No Einstein, no 10-minute PBS tangent needed. But you say you don't like it, so let's move on.
Especially if you're a believer in relativity, then certainly you know that there's no way to know if there's no, you said there's no direct motion, or there's no fixed motion. But clearly, if that's the case, then how could you ever say that the Earth goes around the sun? It makes no sense. That if there's no, you can't come up with that, then it's the same. You know, somebody standing on the sun would see the Earth going around it, and somebody standing on the Earth would see the sun going around it.
Yeah?
That's the sound of science at play. No, that's the sound of a man with a worldview who is refusing to go by observations and instead would rather make something up like the expanding universe that exploded from nothing at the Big Bang and continues to fly out at crazy speeds, you know, past the speed of light. Just insane.
Yeah, sounds pretty zany, but the Big Bang cosmological model is very well substantiated by empirical evidence.
So what he's talking about here with the expanding universe, so this idea actually, for a little bit of the backing to the Big Bang, the expanding universe, this idea, this hypothesis was proposed by a Jesuit Catholic priest named Georges Lemaitre. He proposed this expanding universe, and it came from a primeval atom. That's what he called it, the original beginning of the universe. For any Christians out there, primeval atom kind of sounds different from the biblical Adam, right or wrong? Maybe I'm just hearing things, but yeah, primeval Adam. So that's actually a Catholic belief that it's an expanding universe. Doesn't Catholic mean universal or something like that?
The International Atomic Union named it as Little Guy. He's a popular speaker as well, a writer of popular science, because it's all fiction, folks. He's been a guest and honor at several science fiction conventions. And he also has an honorary doctorate from Georgetown University, the head of the Jesuits. So you can see this guy is fully infiltrated into the Jesuits and the Jesuit story. He's also known as the Pope's astronomer and was named by Pope Francis to be the director of the Vatican Observatory in 2015. So let's hear what he had to say in 2008 in this very telling story about how they're coming out. And we'll get into that a little more after we hear him talk.
A couple of years ago, I was asked to do a Bible study group. I'm thinking Catholics don't do Bible studies, you know. And to do a Bible study group in Houston. Catholics definitely don't do Bible studies in Texas. To do a Bible study group in Houston with a bunch of astronauts. Astronauts, oh, I could do that, yeah. So I wound up at a dinner evening of about 12 couples, all of them astronauts and spouses. One of the guys, half of them were Catholic as it turns out, so much for Catholics not doing Bible studies. One of the guys came up to me and said, you know, I just want to let you know, I believe in the absolute truth that creation was made in the 6 days just as described in the book of Genesis. And that's my religion. I just want to let you know that ahead of time. And I'm thinking, you know, have you actually read Genesis? Where it says the world is with a dome and there's water above and below the dome, you know. Where does the shuttle go? How come you don't get wet?
Recession velocities of galaxies suggest a particular age for the universe, and the detection of the cosmic microwave background radiation that originated during the recombination era corroborates that age.
Yeah, and let's not forget that even in modern day experiments that have been recently done in the last decade, like the cosmic microwave background experiment and measurements, right? What did it find? It found that the Earth was at the center of all of that cosmic microwave background. Oh no, right?
Wow, no. This radiation detected in the 60s is of extreme isotropy, meaning that it looks the same everywhere, and it has absolutely nothing to do with what you're talking about at all. Google it and see. But I think you know that. I think you're borrowing the term to make an unrelated claim and are hoping that your viewers won't look into it.
There are no direct measurements of dark matter. For crying out loud. In fact, mainstream physics right now at this point has all but completely debunked it. So you are so far behind. I mean, oh my God.
Yeah, they're basically looking there and saying, oh, there's a bunch of stuff missing here. And then he's saying that that is direct evidence?
No, guys, astronomers don't just say there's stuff missing here, therefore dark matter. You may think that because you read a blog post that oversimplifies the concept for a layperson and you've convinced yourself that you understand it better than scientists. But in actuality, the people that know dark matter is there and are trying to figure out what it is write papers that look like this. Since you have zero formal training in astrophysics, if this looks too complicated for you to understand, that's not my problem.
Now, dark matter, dark energy. We don't know what dark matter is. It's 85% of the gravity of the universe is dark matter. It's something we don't know what it is. So we just call it dark matter. We don't know what. The universe has some pressure in the vacuum that's making it accelerate in its expansion against the wishes of gravity. We don't know what that is either. We call that dark energy. This sounds like we know something. We don't. I could call this Fred and Wilma, okay? It doesn't matter. We are dumb stupid about what these two things are, all right?
You can't even demonstrate a gravitational wave other than if you want to take Neil deGrasse Tyson going on stage and dropping a microphone and calling that gravity. And you can sit here and say we don't understand this, Dave, but you would be quite wrong because we have lectured on this many times about exactly how it does work and how it is quite impossible. Then you have Einstein's model of gravity, which of course is theoretically the bending of space and time. Again, something that is not demonstrable, is only theoretical, is only mathematical. You have no proof of it whatsoever, and it is just stupid, okay? It makes no sense, and it's a big lie. And I'm sorry, but you're never going to be able to prove it because there is no proof for it, no matter what your mathematical equations say, Dave, okay?
I think I left that in there just to kind of show like a lot of this back and forth between these two to me seems to be very immature. Lots of name calling or stupid this or that or flashing the Dunning-Kruger graphs over and over or this or that or you're not an expert enough or yeah, that type of stuff. I mean, come on, y'all. We're trying to figure out something here that could have a profound impact on people's worldview all over the world. Who knows what type of view someone has because they're an animal, that when they realize the Bible is true, suddenly they now view the world in a different light. They can actually see the beauty of God's creation. Why would we bicker about this stuff or be immature or name call or do these put downs or any of this and basically be bullies? Why don't we just straight bring the facts, like bring it to them instead of this, back and forth? Like let's progress. This is a really actually very important topic because the Bible is reliant on it, and I kind of covered that at the beginning of this video. Like there's a lot of name calling, a lot of stuff I had to edit and tweak out, all the certain words that get picked up, and these types of things. But I mean, let's approach this because in a serious matter because it is a serious matter.
Sorry, general relativity is one of the most corroborated theories in the history of science.
In cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science.
The model predicts the perihelion precession of Mercury with extreme precision. We can see gravitational lensing all over the universe with magnitudes that align with the cumulative masses the light is bending around.
The reason why you can see lights through lights is because in the biblical earth, it's transparent. People have seen stars through the moon. It's a transparent thing, so you can say the light's bending around a solid object or going through a transparent object. It's different explanation depending on the model you're trying to determine, if it's functional or not, if it best describes reality, because we do all have a shared reality.
Relativistic time delay and radar signal travel time near the sun. But once again, if you don't understand any of that, that's not my problem. So that's the bulk of it, but let's quickly hit some of your miscellaneous points.
People talk about the Santiago to Sydney flights. Well, if you go into them with understanding that there are winds aloft and these patterns are traveling, these wind currents are traveling in these patterns, especially towards the southern edge, and their velocities are extremely high, that go up to 199 kilometers per hour, or 136 kilometers per hour, and you add these velocities onto the aircraft flight speed, which gives you a higher ground speed, then all of a sudden these distances are not so impossible to believe.
Commercial plane made it from New York to London in record time. A British Airways flight flew from JFK to Heathrow on Saturday night in just 4 hours and 56 minutes. That's nearly an hour and a half faster than usual. The Boeing 747 sent a speed record for subsonic flights. That means it's slower than the speed of sound. Experts say a strong jet stream helped the plane go more than 800 miles an hour at times.
My goodness.
Now, that's moving. That's flying.
That is a strong jet stream.
That's a life changer, right?
So that is something about honesty. If we actually did have the truth of how things really work, what we really know about air currents and jet streams and transportation and all that, that's one of many facets of life that could be greatly improved if we were honest with one another, if we spoke truth to one another, had respect for one another, wanted to use technology to better people rather than to find other ways to hurt people or deceive people or anything like that. We could get really fast travel, go visit a lot of places really quickly, things like that. That's a little off the topic, though. That's more my opinion. So I guess I'm sorry for putting that in there because I know people don't like opinions. So, or do they? Who knows? Depends on what your opinion is. Is it the right one or not? So you do get these fast traveling planes. It's certainly possible. And we also, we do have the gov in charge of basically the airways and what we're allowed to get and everything. And NASA has a lot to do with the airline industry, and they own the GPS and everything. So that is all something that can be adjusted.
Thing with the flights. You used to say there were no direct flights in the southern hemisphere. Now you're admitting there are. So because they have to go so far on your model, you explain it with these 200-kilometer-an-hour winds, which is hurricane speeds. Also, just find the flights online. Here are several I found in about 30 seconds. They go one way and then return the other direction in pretty close to the same time. So I just don't know what you're talking about here. The flights are consistent with around Earth.
So as you can see here, I have flights from Minneapolis to Tokyo, Tokyo back to Minneapolis, Minneapolis to Dallas, and Dallas back to Minneapolis. There is no difference in these times. They are all equal, which should go against Coriolis, against spin. Rotation is an absolute motion. You can tell which way you're rotating, and there's a definite opposition. If you go against rotation, you would experience a time delay. They say basically, if you void the whole argument of if you travel westward as the Earth spins east towards you, and your destination is approaching you faster, if you void
a faster travel time going west and not being able to reach your destination go east, you're actually also voiding the Coriolis effect, because if everything is stationary everywhere you go, it's stationary. And that's actually part of not having movement when needed or needing movement when it's not there. This is also how Einstein was even able to propose relativity. We don't have any detectable motion or anything like that. As far as the flights go, he is right at the very early on in this movement. For the biblical cosmology, there was a lot of shady stuff going on with southern flights. You could look at the southern hemisphere, and flights would go like 2 hours over the ocean, and then the plane would disappear, and then it would reappear when it was like an hour off coast from whatever continent or country it was going to, uh, if it was by the water. And so there were these types of things. There were not direct flights. People weren't flying there. None of this stuff was shown back then. And even now to this day, these flights along the edge are uncommon. There's a lot of questionable stuff. Qantas just had a flight. I think it's called Q14 was the flight. But Qantas is also, and this actually landed in Darwin, Australia, Darwin of all places. And it actually, Qantas is a company that used Masonic imagery. And so that is very questionable. But there are these things with Southern flights. But we have seen from this clip with the flight from London to New York, planes can definitely fly faster. Planes can definitely get a boost from the wind, and there are winds aloft that do really have a lot of strength to them. And if you can find one stream going one way and another going back, you can fly it at different times, or get there an hour earlier one way or less the other. I think all pilots know wind is a big factor. And there are winds out there. We don't know much about what's out there around Antarctica, so who knows what's being kept, if we're really getting what data, because the international weather, the international sea, the international air, all of these UN places all keep the information for themselves and let out what helps their cause. So this is flights are one thing. Maybe we don't know an exact model to lay out the continents yet, or this or that. Maybe we do. Maybe the Gleason is pretty close. It says it is scientifically accurate as is, and all the latitude and longitude points are in line. But if you do go with the argument of, everything is the same flight time, this or that, you're going to lose out on the Coriolis, on all of that, because you're voiding all motion. So there would never be the Coriolis deviation that people talk about. If you claim Coriolis deviation for like a bullet, then a plane would be the same thing. It leaves the Earth. It would be its own reference frame, and the Earth would spin. So either way, you're going to take one to save your argument for one, but you're going to lose the other because they're diametrically opposed and mutually exclusive options to one another.
Or the the whole nonsense about Aristophanes measuring that the Earth was a sphere and knew its exact size and stuff in 275 BC, but it then took 1,800 years until somebody got in a boat and said, "Let's go west." It's just ridiculous.
Totally irrelevant. Sailing across oceans was very treacherous back then. The statement is also patently false. Vikings were going west hundreds of years before the other European explorers.
The only thing that is obvious is the Earth is obviously and observably flat. You look out, you never see any curve. You see, doesn't matter how high you go. If you send a balloon all the way up to 120,000 feet, there is no curvature.
Out of a perfectly good balloon. What's his name? Felix Baumgartner. He would have been about 2 millimeters above the surface of this globe. That's his edge of space jump. Now, I don't. It's fine. He wants to. I don't have a problem if he does it. But the honesty of it would greatly diminish what I think people thought he was actually doing. And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he said, wow, he's in space, look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
Right, except for that if you take the original source for the video footage you guys show and skip around a little, we can see that a lens effect is causing the horizon to literally invert depending on where it is in the frame. It can look flat, it can even become concave, and it certainly can look round. So when you only show the flat part, what do we call that?
I just had some frozen cherries for breakfast. Anyway, so what he says here about like the cherry picking of frame of horizontal horizon, which the definition of horizontal is a line. And despite what people say about curved, linear, this or that, there is curved and there is linear. You can't be curved and straight at the same time. That's more trickery, like the four-dimensional 3D shape. Here's something 3D, but it's called 4D. And so just imagine. But you can't actually take a curved object. Like, okay, so I have this glass or this mirror ball. It's completely curved, and it's actually, if you take a curved surface, you can't orient the curved object to reflect off of the curved mirror ball and have it become straight, have it become horizontal. You can take something straight that is straight and put it onto a curved surface, and you can make it convex, concave, or straight. But what you cannot do is you cannot take something that is curved, say convex, and make it also appear straight. It will always have a curve to it. So if you can get the horizon to appear straight, that means that it is straight, that it is level. It rises to your eye level too, but it is a horizontal line. It is not curved.
Now we know that there is bendy light, and it's not just the atmosphere. The Earth has a magnetic field. Magnetic fields can indeed perturb and bend the path of light.
No, it can't. Try and demonstrate it.
Which is not Earth rotation, Dave. In fact, it's quite easy to prove that it's the energy of the heavens and of the ether, the luminiferous ether.
Energy of the heavens? That's the most pseudoscientific term I've ever heard. And I'm sorry, I do know what I'm talking about. I studied chemistry. I've done chemistry. I taught chemistry.
This is something I'd like to really quickly address. Dave very often talks about, and like he shows here, the Dunning-Kruger graphs and everything that he's shown multiple times. I've had to edit multiple Dunning-Kruger graphs out of this video, and I left a couple in there just a little bit ago. But the thing about Dave is he's very big on like being an expert. Dave says here that he taught chemistry, studied chemistry, yet he would have to say he's talking about like cosmology and astrophysics and stuff. So he technically wouldn't be an expert. I'll be quick about this, but there's a guy named James Tour who studies synthetic chemistry and says that it's impossible for chemicals to become life. Chemistry and abiogenesis are two different subjects. But then because he is saying that it's impossible for this essential step of evolution to happen, Dave will actually say that this guy is not even qualified enough to be able to speak on this subject. Like, he doesn't have enough credentials. And I think he has like multiple, maybe even hundreds, if I'm remembering correctly, published papers. Journals. James Tour does. James Tour Tour. So he actually does. He'll acknowledge experts when it's beneficial, but he doesn't appear to want to if they are going against the narrative.
And I know expertise is important, it definitely is, but people are allowed to think about things, and just because you don't have any formal training doesn't mean you can't learn things on your own, do your own research, and this and that. And here's something too, like if you want to really get nitpicky with that type of stuff, then I could say, you know, do you have an expert in English? Well, how do you know you can speak then? Do you have an expert in communication? Well, how can I know you're talking to me? Do you have an expert or a degree in thinking? Do you, and you know, is it from Harvard? Is it from a credible university? If you don't have a degree in thinking from Harvard, how can you trust your own thoughts? You know, how do you know you're really thinking? Do you have a degree in studying chemical kinetic reactions, just so you know that your brain is chemicals going off in these exact directions? And can you even show me the mathematical equation for all of the chemical reactions that are required for your brain to have the thought, oh, this person is an expert? Can you show me that on paper? You know, if you want to really get into the expertise and everything, it's possible to really, you know, split the hairs. We're all trying to learn. We're all trying to help one another. If you are a professor, you should be trying to educate people, trying to help people. I might actually have a voice clip up here. I'm actually going through this as like a final, you know, check over, and then I'm going to upload it. So if I said this in the end here too, then I said this again. But, you know, you want to help people learn things.
And because of that, I understand that quantum mechanical calculations allowed us to discern the shapes and relative energies of atomic orbitals that electrons inhabit within an atom. These electron configurations are what give elements their properties, and it is what is responsible for the periodicity that makes the periodic table what it is. This fundamental understanding allows us to predict the properties of certain compounds and therefore build new materials that are inside your computer and your smartphone that you use every day. These calculations also predict things like spectral lines, which connects chemistry beautifully to astronomy, because it allows us to look at the light from an object and know what it's made of. That's how we know the sun and the stars are made of the same stuff. But once again, if you don't understand that, it's not my problem.
Well, he's doing what he was told to do, right? I was
Yeah,
gonna say he's
yeah,
doing what he's told to do, which is to read the, you know, the curriculum, the lesson plan, the, you know, the educational programming.
No, guys, myself and other teachers of undergraduate and graduate level material make our own curricula. When I taught what I pleased.
We were all indoctrinated by the same educational curriculum, the same system.
Also not true. Every country has its own educational system, and some are better than others. In America, we have public and private institutions, the latter of which are not federally funded. The idea that everyone is getting the exact same education, especially the brainwashy one that you're implying, is just not true. Furthermore, science is not doctrine as much as you pretend it is. Even as early as high school, students do experiments to determine how things work. They take a stopwatch and a pendulum or a ramp or whatever rudimentary apparatus, they take some measurements, and they personally derive the equations that science already knows.
This here is my belief, but I believe that science actually works better. The principles are more applied to a biblical earth because things are made with order and design and intent. Things are made to be predictable, whereas with the globe, everything is an explosion, everything is random chaos, there's entropy, things could change at any point. How do you know the speed of light's always been c or this or that? Things could change in the past, or conditions could be different. If the superheated early primordial universe was a thing, maybe light was traveling faster because it had more energy. How would you know? But they'll probably tell you they can measure it.
despite that one website that I was looking at earlier saying that they don't even know really how far away Polaris is, how many, they're off by like 100 million light years or something like that, or could be. So I do think that predictions lend themselves to a biblical earth because things are designed and things have order. We can test these things and they can be the same yesterday as today as tomorrow in a lot of sense. I mean, both models would have to claim observation, but I think it just fits more succinctly with biblical earth.
Students are not handed their worldview like a Bible. They actively create it as they go through undergraduate and graduate programs, doing empirical science, making predictions, thinking critically, and innovating all the new technology that even you get to enjoy. If you had studied science in a formal setting, you'd know that. And finally, let's touch on the conspiracy factor. Seems like a lot of people would have to be in on this, no?
I don't even think that the majority of people who work at NASA are in on it. You know, the guys that are designing satellites and designing the rovers and stuff, I'm very confident that they believe what they're inventing is going up into space. But that's it. It's plausible deniability.
And then what? What happens every day as people carry out their fake missions and receive full salary? Do thousands of people just sit in an empty room and stare at the wall, like George Costanza and the Penske file? It's not just NASA, all scientists. If literally all of physics is wrong, what do physicists do? Or geologists? Do they just hide under a pile of coats every day for 50 years? Who pays for that?
So what was just said right there is the answer. He said not everyone is in on it. These people that are making window ceilings for a space shuttle or a type of fastener, or working on the engine and the turbines for their jet propulsions, because they're jets, not rockets. These are what these people are doing. These people are really doing this type of engineering and design and manifesting this technology. They're genuinely believing it. It would help NASA to have people that are genuine, that genuinely believe what they are doing is what they are doing. Things are very compartmentalized. There's no doubt about it. NASA is a government branch. They do military things. The military is compartmentalized, very secretive. It's a very small number of people that really know that an astronaut doesn't go where they say they're going. It's probably the very high ups of NASA, very tops of the organization, and then a couple astronauts that know. It's very, very, very few people. Everything is a need to know basis, and these physicists and scientists and everything believe the data that they are given, and these people at the very top generate this data or use quantum computing or what types of technology they've had for a long time because they're military. They use that data and then give it to them, and these people really do real equations, really do solve for what they believe what would be the correct answer if it was true. I'm sure they're very smart people. They know how to do these brilliant equations, but I think it was Tesla who said these people have replaced reality for mathematics. Just because you can do a mathematical equation that can apply to reality doesn't mean that every mathematical equation will always have a real world application. These people are doing real maths. They're engineering real things. The rocket really does probably have, a fastener that on the or a window ceiling that would hold. I don't know if they even test them in a vacuum. I mean, we know spacesuits wouldn't be able to withstand 15 pounds of pressure. Do you know how hard it would be to wiggle your fingers with a suit that rigid? But these people do make this stuff genuinely. I mean, I think all people of biblical earth, I think, agree to that not everyone has to be in on it. These people just don't know that their rocket is gonna, or so-called rocket, their jet is gonna go crash into Point Nemo.
or the Bermuda Triangle, or wherever these things go and land in the ocean, the water. What are they called? Water graveyards or something for planes. This is what is out there, and this is no one is denying that these people really do solve equations, really do engineer these things. They just don't go to to space because you can't.
In a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
We could go all day, and the globe busters, like all have an endless list of talking points.
So that's basically the end of it. He recaps the stuff he went over. So I'm gonna cut that off here because I've already gone over the stuff that he has covered, and I believe I've answered everything that he brought up in this video. Other videos that he's done on this subject have been debunked. There is a channel called Don't Sphere the Truth, which is has like 5 or 6 videos that cover another video that Dave has done, because Dave is a very promoted and a very popular, and a lot of people nowadays, with the way that the searches work, you don't get anything that you used to get years ago. And seeing all this stuff, and I hope at least some of you people that are pro globe at least understand for people, because we're trying to everybody's trying to learn. We're trying to help humanity get better. Hopefully all of us are. Very few people are truly rotten and evil to their core. But if hopefully at least with some of this, like just seeing Don Pettit just recently here saying it's painful to build back our technology and all that, we destroyed it. Hopefully you can try to understand how some people get into this mindset of like, wow, there is kind of some odd, funny stuff. That's pretty weird that Qantas would use a Masonic logo and then be the company to make this one flight, or do this or that, or same like with One More Orbit. These people are royalty, and they're connected. They are in clubs and all that. They work with astronauts when they took that flight and everything. So it's a very small pool of people. So I wanted to cut that off here, and just say, thank you for watching this video. It's quite long. I tried to go in depth as much as I could and answer a lot. I probably could have made it longer. I probably could have made it shorter. Hopefully this is kind of a sweet spot. And I just wanted to say too, all of this stuff, it's pretty odd. This whole video, like, he doesn't really at all address that the Earth, doesn't feel like it moves, or that there is curve that we can't measure, or this or that. I don't know if Dave is aware of 4 lights being over water at 5, 6, 7, and 8 miles out, and they are all in a straight line. That would not happen. They're also all just a foot off the ground and being viewed from a camera that is below a foot, so actually angled upwards, and seeing all of these lights in a level line, straight planar line. And all, conjecture about how this or that works, or the sky, or how land is laid out. The empirical fact remains that we see planarity over water when it is in a large basin, when it has a gradual lipping, when there's no allowance for a meniscus to form due to surface tension, when the water isn't falling through the air and under its own surface tension. When water is able to break its surface tension and seek its own level, that is when we will see in a large basin, like a lake or an ocean, that there is no curvature. It's planar. There's also no motion that we can show. Take which side of the Coriolis you want. It's not there. We feel still. Relativity relies on us measuring no motion to the Earth. That's why Einstein had to try to nullify the Michelson-Morley experiment with mathematician tactics. And so all of this conjecture about how something works, well, we don't have every single thing figured out. Like, we are told that science already had done with the, with the globe, that they're all knowing essentially, and can tell you the composition of a planet's atmosphere that orbits a distant star. They can, if an alien bug burps, they're going to tell you what that bug ate because of the gas composition that came out of it, what it had for lunch. And so, that's kind of the claims of today that we hear a lot of. And so all of this stuff remains. There is no way to show motion, admittedly, as long as you subscribe to Einsteinian cosmology. And there is no curvature. It's level. It stays level. The horizon rises when you go up it stays level, or stays rising to your eye. It's a straight line. We can put lights out and they stay straight over long distances. You can see further than you should. So these are those two things are the quintessential points that do not get addressed and should. With that being said, I'm going to close off this bit with Dave, and I actually do have one more kind of little bonus thing. Personally, this video is on a playlist that my friend didn't even tell me that he made about why the Earth is a globe. I've had some issues with this biblical cosmology for a few years. I'm sure many of us have. And please, pro-globers, if you can, please just understand, people don't want to go through, the family isolation and the scorn and the mockery and the friends that do this or that. Nobody wants that. We just, for people who really do see that the Earth is how it is, it's very important because this will bring us back to our original stature in cosmology and who we are and where we are and what we are. And it all has to do with the Bible, which it agitates a lot of people who are very worldly. This is all biblical. And so one of my really good friends who I've been friends with since I was like 5, he has this playlist, and this video of Dave's was on there, along with this other video here that I'm gonna play. It's just really quick. It's like it's a minute, and it just shows the angles people look towards the moon during a particular eclipse. You could technically do this any day of the night or whenever for the sun or moon, but it's gonna show that the arrows don't make sense on the biblical map, and they do appear to look like they make sense for a globe. But real quickly, I'll play the video. I'll probably play it as I'm talking here. So as you can kind of see, though, so one thing is that the data that is given is spun through these agencies, so they can take biblical data, biblical Earth data, plug it into a Lorentz transformation type equation, transform it into what it would be like on a globe simulation, and then put it out as that kind of data. But the other thing too, even if the data was what it is, which I mean it's time and date, so I think that it's accurate as far as the time and date data. But the thing is, look at where the arrows end up on the globe. They're pointing up and to the left. And I live in the north. I live in at about 40 some degrees, lower 40s degrees of latitude. And the thing is I've never looked north to see the moon. I've never had to look into the northern sky. These arrows are pointed north, pointing towards the pole, not towards the equator where the moon would be overhead. So it would have to, all of these arrows, because there's some from above the equator and below the equator, I believe, they should converge towards the equator, and they do not. So I wanted to quickly debunk that video just in case my buddy ends up watching this. But to everyone else, this video is kind of irrelevant. Sorry for taking even more of your time. This is a long video. So I just want to say thank you for bearing with me. Let me know what you think. If you have anything you want to add or say or contest or support or this or that, please feel free. Just please be respectful. Really, it's a big thing to me. Convey facts. Don't spout like mean bullying put downs and everything. Other channels might do that, other people and everything. I'm not trying to do that. I really just want people to talk. Like, let's just talk about this, because communication is very important, especially in the era that we live. And wow, I'm really ranting. This is like a 10-minute audio clip. So yeah, with that said, I'm gonna close off this here. Thank you so much for watching. And yeah, please have unconditional love for your fellow man. Follow the teachings of Jesus. He gave us the template for how to live, and if we lived like Jesus, there would be no sin, no qualms, no famine and war and all of that. We need unconditional love. It's so important to humanity's integrity and to prevent the degradation of our moral fabric. Jesus Christ is King. We are all loved by our loving God, by Jesus, more than we could ever know. What a glorious thing to be able to be here, to worship our Creator, and to love our fellow man, and to enjoy this experience of the physical with our souls. It's an incredible thing. Glory be to the Most High. God be with you all.